Uh, Hello my dear friends, welcome all of you. So how you all are? Hopefully you are fine, good, and your preparation is going on in the well direction. So my dear friends, today what I have to do, we will take all the most important questions with respect to the Airport Authority of India AAI. Here I will discuss the 11th class physics and all the topic from which you have seen in the last session when you have solving the question of your PYQ. So what was the portion is important, I have tried to take all that question here. And one more thing my dear friends, I want to tell you, please keep patience since you have to discuss lot of question there, so it will be little bit lengthy session. So stay positive and try to answer the question. And one thing I want to be assured, most of the question of the 11th class physics will find from that section, most of the question, okay, because you have seen what type of question, what is the difficulties level in your exam. Accordingly I have framed the question here, so it will be very helpful. So the first question on the screen is, my dear friends, here we can say first question is that the moment of inertia of a body depends upon, moment of inertia is going to depends upon on which thing, that is the question, right? First question, its angular velocity, its shape and mass distribution, its linear speed, its temperature. So moment of inertia of a body basically depends upon which one? Oh, obviously it is not the angular velocity, it is not the linear speed, not the temperature, basically it depends upon the shape and mass distribution, right? Shape and mass distribution, summation mr square na. Here I am coming with the solution also. We can say I is equal to, I is given by summation of mi ri square, right? So it is depends upon the mass and distribution, we can say. So try to be keep in mind, okay, I is given by that one, which depends upon the how the mass is distributed relative to the axis of rotation. So correct answer is what, my dear friends? B4 Bombay is the right answer. Come to the next question. The rotational analogy of Newton's second law is, rotational analogy, what, my dear friends? Rotational analogy of Newton's second law is, option A is F equal to ma, option B is tau equal to I alpha, option C is P equal to mb, and option D is half mb square. My dear friends, mostly student is going to be make confused, or they are going to give the wrong answer. They think, okay, Newton's second law is what, F equal to ma, and they are going with the option A. But my dear friends, option A is wrong. It talk about the rotational, it not talk about the linear motion, right? It talk about the rotational motion. So in case of rotational, do you know force is needed for the, just you can say compare, force is needed to make a motion or to make a acceleration. Similarly, if you have to be rotate anything, there need of torque, so here it will be torque. What is the mass? Whatever mass is there, same thing will be played by the moment of inertia there. And here A is linear acceleration, here alpha is coming out to be angular acceleration. So tau is equal to what, I alpha. This is, you can say, second Newton's second law analogy in the rotational component basically. So my dear friends, as you know, try to be remember, force is required to get acceleration in the linear motion. Same thing, torque is required to get some angular acceleration, and here whatever work of mass, same thing is going to perform by the moment of inertia. So try to be remember. Sometimes question is given to ask, sometimes in the exam you have find that they will give, okay, for a given tau and alpha, for a given tau and alpha, if, or for a given alpha, let's assume for a given alpha, if I is high, then what will be tau? For a given alpha, if I is high, torque will be the high, right? So try to remember that type of question sometimes also going to be asked, or either they can say tau is constant, okay, if I increase the alpha, what will be I? If I is high, what will be alpha? So we can say if I is high for a given torque, alpha will be the less. So that type of analogy you will find in the exam also. So try to be remember that point also, my dear friends, it's also important, you will find in the exam, okay. So you can say torque causes angular acceleration, alpha in the body, and the moment of inertia is the resistance to the rotational motion. Come to the next question. Angular momentum is conserved. When angular momentum will be conserved? A net force is 0, a net torque is 0, option G net angular velocity is 0, okay, and option D is acceleration is constant. Angular momentum, when angular momentum will be the conserved? When angular momentum will be the conserved, my dear friends, we can say when net torque is 0. Whenever net torque is 0, then angular momentum will be the conserved. Try to remember that point, various times you will find the question. Angular momentum is conserved when net torque is 0. So the correct answer is what? B. Net force is 0. That is for the linear momentum, not about the angular. It talk about the angular. Net force will be 0, then momentum will remain conserved in case of linear motion. You know na? Momentum is what, my dear friends, in case of linear motion if you talk. So simply we can say, sir, mass into velocity. So it will be conserved when net force is 0 in case of linear motion. But if we talk about the angular, then net torque should be 0. As I told you, whatever function of the force in the linear motion, same function is the torque for the angular you can say momentum or angular motion. So try to remember that point. So correct answer is what, my dear friends? B for Bombay is the right answer. Okay, come to the next question. What is next question? And that is explanation is there. You can join our Telegram and WhatsApp group where I will share all that PDF there. That PDF I will share there. Okay, now the question is that a disk is rolling without slipping. Okay, so its kinetic energy. Now first thing, sir, what do you mean by the without slipping, my dear friends? So a rolling, okay, suppose this is one of the track over which something is going to be rolled. That is one of the roller. Okay, it is going to be rolled. Thus without slipping means here the velocity is what, my dear friends? V. So V equal to what? Omega r. Whenever V equal to omega r, where r is radius, is happening, then it is called without slipping. If V is not equal to omega r, then slipping can take place, right? Even if in your bike you are going to take the sudden brake, then your vehicle is going to be slip. In that case, V is not equal to omega r. That's why it is slipping it takes place there. So now the question is that a disk is rolling without slipping, means there is no any slipping, then total kinetic energy. So in you can say the without slipping, so it is called here rotation as well as translation, both. Here rotation because it is rotate as well as it is move ahead, so translation both. So in this case both rotational and translational is responsible. So if you talk about the total kinetic energy, obviously it will be sum of the rotational and translation. So we can say B for Bombay is the right, sorry, C for Chennai is the right answer, both rotational and translation, whenever no slipping is takes place. If the slipping is takes place, my difference, then in that case we cannot select that. Okay, so in the vehicles we have seen how the slipping is takes place. Sudden you suppose your vehicle is moving at a faster rate and take a sudden brake, your vehicle is going to be slip down. Okay, we will talk why slipping is takes place, and in another session I will take why slipping takes place, what is the cause. So my dear friends, what is happening, there is a brake drum, right? In vehicles your brake drum is there, na? So whenever you are going to apply the brake drum, so suppose that is the shoes, so that come in the contact and artificial friction is going to be applied. Due to that their rotation is changes, yet omega is sudden become 0, but V is not 0, na? Omega, you have just applied the brake, so omega makes you sudden 0 because drum is not rotating now, and that wheel is not rotating now because of that artificial friction applied by that brake drum. But V, who is responsible for V? No one can stop, no sir, only friction is responsible, no sir. So V cannot stop, that's why your vehicle is going to be slip. Omega you are going to be stopped because by applying of external force agency, but V is, no one is here responsible for the V. Yes, if surface is very rough, that can be reduced. That's why in the smooth surface the chances of slipping is higher, na? Why? Because their friction is less. So try to remember that point, my dear friends, it's also important. Come to the next question. Next question is that what happened to angular momentum if moment of inertia double and angular speed half? Angular momentum, they talk about the what, my dear friends? Angular momentum, na? So my dear friends, we can say, sir, angular momentum is equal to what, my dear friends? I alpha is equal to what? I omega, not alpha, let me correct. I omega, linear is what? Mass into velocity. So instead of mass you are going to use moment of inertia. In case of linear velocity you are going to use the angular velocity. L is there. So sir, what happened if the moment of inertia is double, so 2I, and angular speed is half, omega upon 2. So sir, ultimately it is I omega, na sir. So it is not going to be changed, it is not going to be same. So we can say it will remain same, it will remain same. So what will be the correct answer, my dear friends? C for Chennai is the correct answer. Okay, well, coming to the next question, that is the solution. I will share that PDF, don't worry. Next the question is that rotation kinetic energy of flywheel. The problem is that a flywheel of moment of inertia is given. Moment of inertia means I is given in the question, 4 kg per meter square, 4 kg meter square, is rotating at 10 radian per second. So omega is also there, I is also there. Okay, what is its rotational kinetic energy. They are only going to be interested to calculate the rotational kinetic energy, my dear friends. You know, if I will ask what is linear kinetic energy, linear kinetic, you can say, sir, half mv square. But in this case, this is rotation, so just convert half. Okay, instead of mass, what you have to be used? I, right? I. Instead of velocity, which velocity? Angular velocity na, angular velocity na. So this will be the omega square. So you can say the rotational kinetic energy is what? Half I omega square. It is just analogy of linear movement, linear motion, right? Mass is replaced by I, velocity is replaced by omega, acceleration is replaced by alpha, angular acceleration, and then we'll get the answer. So just put that value na, my dear friends, nothing else na. Just put that value. Simple question. It was half, instead of I we can say, sir, 4, and omega square is your just. So by solving this we will get the answer. How much? Simply na 200 na yaar, 2 2 ja 4 and 100, 200. So simply we will get A for apple is the right answer. Simple question it was, but you have to remember that one formula only. Next, slightly I will increase the question difficulties level. You can see here half I omega square. From that we will get that one. Clear now, my dear friends? Okay, that is the next question on your screen. What is next question? Next question is that, my dear friends, a solid sphere of radius is given 0.2 meter, roll without slipping. Okay, at that time it is rolling, there is no any slipping, it takes place with a linear velocity given 3 meter per second. Find out its total kinetic energy. Mass of a sphere is given 1 kg. Now, my dear friends, in this case it is having both a solid of radius is there. This is one of the solid sphere. The radius is given 0.2 meter, and it is going to be rolls without slipping. So sir, there will be both kinetic energy due to the both. What question is that? Find total kinetic energy. So if you have to be calculate the total kinetic energy, so it will be kinetic energy due to the rotation plus kinetic energy due to the translation. Kinetic energy due to the rotation as well as kinetic energy due to the translation. So sir, I know kinetic energy due to the what? Rotation, half I omega square. What will be that? Half I omega square plus half mv square. Now the question is that, sir, in this question, in that I is not given, na sir. Moment of inertia is not given, na. Yeah, really. Here moment of inertia is not given, sir. So first of all, you must have to be know how you can calculate the moment of inertia in case of solid sphere, right? Few example I will give. Try to remember that value. I have came with the answer. See, in case of moment inertia for solid sphere is given by I is equal to 2 by 5 mr square. Try to remember what is I for the ring, what is I for the solid disk. That value you have to remember. Directly question will find. Okay. So in case of solid sphere, we can say, sir, I is given by 2 by 5 mr square. Okay. So if you talk about the, my dear friends, if you talk about kinetic rotation kinetic energy is equal to half I omega square, half 2 will get cancelled out. So it is coming out to be 1 upon 5 v, half r mr square, m omega equal to, you can say, sir, what omega na, v equal to omega r. So from there, if you want to be calculate in the form of v, so we can say, sir, omega equal to v upon r na. So just put that value here, just put that value. Okay, they have used the capital R, no problem. So from that we will get 1 by 5 mv square, and kinetic energy will have half mv square directly. Just put that value, and by solving that we will get the answer. It is coming to be 6.3 joule. So my dear friends, it was a good question, and that type of question we can expect in your exam. They may ask. So what was the answer? 0.6, right? 6.3 na. So A is the right answer. So my dear friends, so what's my target to do that type of question? That you have to remember the moment of inertia for the various profile. Ring, disk, solid disk, hollow disk, in all that you have to be remember, going to be asked in the exams. That was my target to doing that question here. Try to be remember. Okay, that is the next question, my dear friends. Oh, one miss. Solid break above the elastic solid which break above the elastic limit. Solid which are going to break above the elastic limit. This is known as what, my dear friends? Solid which break above the elastic limit. Above the elastic limit. Solid which break above elastic limit, you know, my dear friends, like that na. So that point is called elastic limit. So solid which break above the elastic limit, after elastic limit it is going to be break. So simply we can say that will be called as ductile. Beyond the elastic limit, yes, it fails below the elastic limit, we can say that is called is what, brittle material. So make it correct, option is mistake there. Okay, now that is the next question. The question is that if two equal and opposite deforming force are applied parallel to the cross section area of the cylinder as shown in the figure. Okay, there is a relative displacement between the opposite face of the cylinder. There is a relative displacement between the opposite face of the cylinder. The ratio of change in length, basically that is upon that, is known as what? This is known as, my dear friends, this is known as which type of strain? Option A is longitudinal strain. Option B is what, my dear friends? Option B is volumetric strain. Option C is shearing strain. Option D is Poisson ratio. So if you talk about the longitudinal strain, so what will be? This will be change in length upon original length, but due to that there is no any longitudinal strain is going to be observed, because there is no change in the length. There is no change in the length, so you can say no longitudinal strain is there, sir. Okay, so now what is Poisson ratio, sir? Obviously it can't be, sir. Poisson ratio is the basically the ratio of lateral strain to the longitudinal strain, so it can't be. My dear friends, sometimes what's happen, you can eliminate the option very easily and get the answer quickly. Yeah, it will help you a lot during the elimination. If you don't know all the options exactly, so in that case you can eliminate the option and easily will get the answer. So here we can say, sir, longitudinal can't be, sir, because no change in length is, sir. Volumetric strain, if you talk about that change in volume upon total volume, this is coming out to be, but sir, this force is what? Shear. So this is called is what? Shearing strain. Simply we can say that will be called is what, my difference? Shearing strain. Change in that length upon that length is known as what? Simply we can say the shearing strain. So Chennai is the right answer. That is the next question. Within elastic limit, which of the following graph correctly represent the variation of extension in the length of wire with external load within the elastic limit? What limit, my dear friends? Elastic limit. Do you know what is elastic point? Yeah, in the class I have discussed about the elastic point, if you remember. Suppose that is one of the object, right, and I am going to apply the force, let's assume F. So what is elastic limit? Suppose I am going to apply the force F, because of that some extension can take place, because this is a tensile load, so extension can take place in that material. But once you remove the load, after that they will try to retain their original shape, right? Okay, like that. So they will try, once you remove the load, they will try to retain original shape. So which property is responsible for that? Obviously this is called what? Elastic property of the material, which is responsible to getting the what you can say the original shape once the load is going to be removed. So sir, and my dear friends, in the stress strain curve for the mild steel, I have clearly mentioned that till the elastic limit there is a linear relationship between the stress and strain. Basically that is for the proportional limit, but the difference between proportional and elastic point is very very less, so you can consider even up to the elastic limit. So in the elastic limit we can say, sir, that is going to be takes place something like a linear relation. So correct answer will be what, my dear friends? B for Bombay. Can anybody can tell me what will be this one, this one, this one? You have to make comment for which material we can see the curve like that, for which material we can see that this is known as, if you have a pseudo-plastic fluid. Do you know that is for called pseudo-plastic fluid? This is for the pseudo-plastic fluid. I will teach you in the fluid mechanics part, or you can say the mechanical property of the fluid. In that I will discuss about the types of fluid is there, in which we will going to discuss about the types of fluid. So that is called pseudo-plastic. Try to be give all the answer, but here up to the that is the proportional limit is takes place up to the elastic limit. So the correct answer is what, my dear friends? B for Bombay is the right answer. B for Bombay is the what, my dear friends? Is the right answer. Even from the Hooke's law also know, from the Hooke's law stress is proportional to strain till which limit? Yeah, a proportional limit, yeah, till the proportional limit, but in certain case we can say up to the elastic limit, because gap between the proportional and elastic limit is very very less, so we can say like that. So that's why we can say power is 1, so linear relationship is there, that's why linear is going to be takes place. Simply we can say Hooke's law within elastic limit, that so option B represent the correct graph. Now my dear friend, that is the next question. The elastic energy stored per unit volume in a stretched wire is given by half stress upon y. Okay, that must have to mention here. Y is Young's modulus of elasticity. In the question it is not mentioned, but it must have to be mentioned. Y is Young's modulus of elasticity. Young's modulus of elasticity, it should be mentioned there, otherwise a student can get difficulties. This is what Y is Young's modulus of elasticity. So the elastic energy is stored per unit volume stretched wire. So my dear friends, suppose per unit volume, this is stress, this is strain, so that area we can say, sir, half of what will be that area, half of stress into strain. So even if you go through the option, my dear friend, that is also known as strain energy. Later on I will teach you, this is basically now nothing else, but it is known as what, my dear friends, strain energy. But if you go through the option, you will find that, sir, it is given in the form of stress, right? All the option is present in the form of stress, so I have to be convert that one in the form of stress. So we can say, sir, okay, that strain energy given by half stress. You know strain, you know what strain we can write, we can say, sir, stress is proportional to strain. If you remove, according to Hooke's law, if you remove proportionality, we can see it is coming out to be E into, epsilon. This is known as strain. Here instead of E they have used the Y, so Y into epsilon. So instead of epsilon, can I write stress upon Y? Yes, sir, that put the value. So we can say, sir, stress upon Y, stress square upon, so it is coming out to be stress square upon 2y. So what, stress square upon 2y? Yes, my dear friends, before Bombo is the right answer. This is also a strain energy. You know what is the function of strain energy? Whenever the impact load is there, so material having high strain energy, they can absorb the more impact load, more shock load, when they are more stable in the shock load if the material having high strain energy, right? And yes, that is the strain energy. Basically that type of energy, it is two types, one is resilience, another one is what, toughness. So toughness is basically, energy absorbed by any material before the fracture point, so that is called your toughness, and the energy absorbed up to the elastic limit, this is simply we can say the resilience. So here per unit volume they have asked, so simply we can say sigma square upon 2y. Sigma is here stress, so it was the correct answer. Here we can say, in that must have to mention that what is Y, otherwise, because mostly in the engineering college students are going to be used E as a Young's modulus of elasticity, but they have used in the Y, they have used here Y, so that have to be mentioned so that a student will not find any difficulty, otherwise they get confused. Next question, a sphere contract volume by 0.01% when taken to the bottom of sea 1 km deep. How much km? 1 km deep. The bulk modulus of the material of a sphere given sea water may be taken as density is given basically 1000 kg per meter cube. So the sphere contract volume, whenever, suppose my dear friends, that is the sphere, okay, you have put in the water, how much km deep? This is the samundar sea water, okay, and you have put that sphere here, where sir? Here, and how much deep that is? 1 km deep is there, okay. So a sphere contract and their volume is going to be contract by 0.01% when take to the bottom sea of 1 km deep. The bulk modulus of the material, what will be the bulk modulus given that? Okay, so what is bulk modulus, my dear friends? Anybody have remember what is bulk modulus? Bulk modulus is going to be denoted by K. That is basically we can say change in pressure upon volumetric extent. Okay, I have solution, I am coming that one. So here see my dear friends, first we can say, sir, bulk modulus, as I told you, okay, they have denoted by B, but sometimes it is going to be denoted by K. So we know K is equal to what? P upon volumetric extent, change in volume upon volume. So now first question is that, sir, what will be pressure there, sir? What will be pressure? So you can say, na sir, pressure is rho GH, na sir, rho GH, so rho is given here, sir, how much? 1000 simply. G, since in the exam calculator is not there, so use the 10, okay, in your exam calculator is not there, so don't use 9.81. At the later once I get the answer, I will choose the closest answer, but don't put 9.8, better to take 10. Rho GH, H is given 1 kilometer, that means 1000 meter rho GH. From that you will get the P, and volumetric strain is itself is given here. dB upon V is given, sir. dB upon V is given in the form of percentage. That put the value simply. here I have come with the solution. So we can say, sir, here dV upon V is okay. So in this question it is given liter in the form of what? 0.0.1%, huh? So here we can say, sir, dV upon V 0.001 upon H upon that. So that value is coming to be del V upon V. P is equal to coming out to be, okay, 9.81 they have chosen, but don't worry, you can choose the chain also. And B is what? P upon del V upon del V. So P upon K, or you can say here B they have used, no problem, notation mostly K is going to be used, del V upon V. Okay, so P is there, 9.8. okay, in the option it is in the 9.8. so put that 10 to the power 6 into 100 upon how much? 0.01. okay, del V upon V, na. So change in that one, na, percentage, na. So 0.01% means what, my dear friends? We can say 0.01 upon 100, na. So by that you have get del V upon V, huh? That is called volumetric strain. Del V upon V is what? Change in volume upon original volume is known as what, my dear friends? Volumetric strain, right? So you have get the once the volumetric strain, from the hydrostatics law, we can say P equal to rho GH, and by that you will get the answer, and it is coming out to be that one. Next question, that is also a good question. How much pressure should be applied on a liter of water? How much water on a 1 liter of water is there if it is to be compressed by 0.1%? How much by it is to be compressed? 0.1%. Bulk modulus is given here 2100 megapascal. So that time how much pressure should be applied? So we can say, sir, bulk modulus is K, na. So I know, sir, K is given by P upon volumetric strain, huh? dV upon V, na, sir, huh, sir, dV upon V. So in the question bulk modulus is known here, sir, how much? 2100 MPa, sir, megapascal. Okay, and how much pressure should be applied if it is to be compressed by 0.1%? So what is dV upon V, sir? What is dV upon V, sir? Sir, 0.1 upon 100, na, sir. So dV upon V is known. Can you calculate P? Yeah, obviously I can do that, sir. I can do that, no problem. So my dear friends, I have came with the solution here with the data. Here we can say V, and from that we will get the volumetric strain. Okay, one more thing here, what you have to be put little bit more attention. Here it is given in the form of liter, huh? And in here it is given in the form of liter, but volume in the form of meter cube, na. So convert it in the meter cube. So try to remember 1 liter equal to 10 to the power minus 3 meter cube. Try to remember, okay? 1 liter equal to how much, my dear friends? 1 liter is equal to 10 to the power minus 3 meter cube, huh? Because ultimate you have to be get answer in the megapascal, all that. So convert in the SI unit, huh? So 1 liter equal to 10 to the power minus 3 meter cube. So by doing that we can say, here I am coming with the answer, okay, here. So that and del V upon V, you have get that one. Bulk modulus is this. From there we can use the P, just solve, and by solving you will get the 2100 kilopascal. So even P is itself 2100 kilopascal we get, but yet it was megapascal, na, but it is what? Kilopascal. So we will get that. That was a little bit good question. So volume is given here, but in the liter first convert in the meter cube, and bulk modulus is given here. You have used the notation B, otherwise mostly bulk modulus you are going to use the notation K. So no problem is there. And bulk modulus is what? P upon del V upon the V, and by that we will get the answer. So even it was an easy question, but yeah, you have to remember all that formulas, my dear friends. If you forget, obviously you cannot move a single step. If you don't know the formula, how to be proceed. That's why in that exam formula is important. Don't be forget. Write several times, so that at the end of the exam you will not find difficulties. Otherwise, now if you are not going to write the formulas, you are not going to devise, especially in the weekly basis, you have to devise all the content, so that all the formulas should be in your tongue, should be in your mind whenever is needed. What type of formula is needed, you have to be used there. Otherwise you will find difficulties, not even in the physics, it will be in all the subject. So work on that, and as you know, YourPedia team have launched a specified module for AAI, so you can join that module also, and you will find the differences, and yes, you will enjoy the session also. So my dear friends, that is the next question on your screen. The question is that a spring is a spring is made up of steel, not of copper. Why spring is made by of what? Steel, not of copper. Anybody can tell me what is the cause behind that, my dear friends? You know, if you ask in steel and copper, which one is more elastic, my dear friends? In case of steel and copper, which one is more elastic? Try to remember, steel is more elastic than that of copper, and that's why in the spring construction, manufacturing of spring, you are going to use the copper you are going to use the steel rather than copper, because steel is more ductile compared to that of copper. Okay, so the correct answer is what, my dear friends? A for apple is the right answer. A spring is made up of steel, not of copper, because steel is more elastic than that of copper. That's what is preferred. Oh. So this is the next question. Which of the following is correct? Only solid have fixed volume. That is easy question, everyone can do that. Only solid have fixed volume. Solid and liquid have fixed volume. Both solid and liquid does not have fixed volume. Liquid have fixed volume and solid gas does not have fixed volume. So what could be the answer, my dear friends? Tell me, what could be the answer? Anybody? Which of the following? Only solid have fixed, only solid? No. Sir, solid and liquid have fixed volume. Yes, it could be right. Both solid and liquid does not have fixed volume. No. Liquid have fixed volume, but solid and gas does not have. Oh, that is a very easy question. Even your class 8th, 9th standard student can answer that question very easily. So we can say solid and liquid have the what, my dear friends? Fixed volume. So B for Bombay is the right answer. That is the next question. Okay, that answer you have done. That is the next question. Pressure is applied to an enclosed fluid, is transmitted undiminished to every point in the fluid and the wall containing vessel. This law was first formulated by which law it was formulated? Pressure applied in enclosed fluid is transmitted undiminished to every point in the fluid and the wall containing vessel. This law is calculated by the Pascal law. You know, in the hydrostatics fluid, at a given point, pressure is same in all the direction. And you know, my dear friends, on the basis of Pascal law, various instrument, ramjet, hydraulic press, that all are working on the same and the principle of the Pascal law. It will be helpful. Later on some question you will find on that concept. So that is basically known as Pascal law. In layman language we can say, in a statics fluid, at a given point, the fluid in all the pressure in all the direction should be same. Otherwise, fluid cannot be static. If there is a pressure difference in the tangential direction, the flow will start flowing. So it could not be in the rest. If they have to be rest, obviously at a given point here, suppose that is your fluid. Okay, so take any point. So whatever pressure in that direction, in all the direction pressure should be same. Only then it remains in the rest. So C for Chennai is the right answer. Pressure is a scalar quantity. Now the question is that pressure is a scalar quantity. Why? It is the ratio of force to area, and both force and area are vectors. Farzik option is there. It is ratio of magnitude of the force to the area. It is ratio of component and force normal to the area. Yes, my dear friends. It is the pressure is a scalar quantity because it is the ratio of the component of the force normal to the area. My dear friends, that is not the main reason, but according to option I have to go with the option Chennai, but that is not the main reason to being a pressure as a scalar quantity. My dear friends, pressure have both magnitude and direction, but it is a scalar quantity. Why? Because anything could be the vector only if they fulfill the three conditions, not two. Mostly students generally remember two conditions, that if they have magnitude and direction, but they forget the third condition, my dear friends. Third condition is most important. A vector could be only when if they have magnitude, direction, and yes, must follow the vector law of addition. But with the pressure, what is that? Pressure have magnitude and direction both, but they don't follow the vector law of addition. That is the main cause. According to option I have gone with the option Chennai, but that is not the main cause to the pressure to be a scalar. Actually, pressure don't follow the vector law of addition, and that's why it is called a scalar quantity. Even two quantities there, my dear friends. One is electricity or current we can say, or other one is pressure. Even both have magnitude and direction, but both don't follow the vector law of addition. That's why these two are considered as a what? a scalar quantity, even it have magnitude and direction. So try to remember that point. So but yes, other than that, most of the quantity they have magnitude and direction. By default they are vector. That's so mostly a student is just going to remember, okay sir, if they have magnitude and direction it will be considered as a vector. But third point, they are going to usually forget about the vector law of addition. So try to remember that point. And that is only two quantity, my dear friends, pressure and current. They have magnitude and direction. Still it is a scalar because these two can't follow the vector law of addition. Now you can ask, what is the vector law of addition? If I will derive, it will take longer time. So in the session I will discuss about the vector law of addition, so don't worry. So my dear friends, that is the next question. Two springs of a different cross section without needle filled with water are connected with a tightly fitted rubber tube filled with water. Okay, distance of the smaller piston and the large piston are 1 cm and 3 cm respectively. Okay, if force of 10 Newton is applied to the smaller piston, then the force exerted on the large piston is, see two springs are different cross section. See there, that is something, suppose that is the, okay, these two cross section. Okay, in that you have filled the fluid. In that what you have filled the fluid. So that all the fluid in between that all the fluid, they have two different cross section. Okay, that will also work work on the Pascal law, we can say. So two spring different cross section without needle filled with water and connected with the tightly fitted rubber tube. Okay, tube is there tightly fitted, well, no problem. With water, diameter of a small piston and large piston, that diameter here is one of the piston, so that diameter is 1 cm and that diameter is basically given 3 cm respectively. The force at 10 will applied at smaller end. Here force is applied 10 Newton. So the force exerted at the larger piston, what will be the, that is the another piston. So what will be the force there? That thing is going to be asked, my difference. So from the Pascal law, what you have known, at a given point, at a given depth, pressure will be same everywhere. So what is their pressure? So we can say, sir, pressure is there, at that air pressure is what? Force upon area. Force upon what, my dear friends? Area. And that pressure should be equal to that one also, because at the same height the pressure must be same if fluid in the statics condition. So we can say, sir, here F upon A. So simply we can say, sir, 10 Newton upon area pi by 4 d square equal to F upon force upon area pi by 4 d square 3. Okay, I have to get cm square. Okay, it will get cancel out, pi by 4 5 by 4 will get cancel out, my dear friends. So how much? It is directly coming out to be 90 Newton. Na? So Ft is 90 Newton. So see concept, just you have applied the 10 Newton force, you can lift the 90 Newton body. Suppose just you have put 1 kg a block, 10 Newton means 1 kg a block, na mg, na, let's assume you have just put it 1 kg a block. So here it can lift the up to the 10 kg block, 90 Newton means, sorry, 9 kg block. So that is the beauty of that concept. In that hydraulic plate, hydraulic ram, hydraulic jet, all that are going to work on that principle, my dear friends. So it is a very, very helpful, very, very important data if they are going to be asked in the exam. So that is the concept you have to be remember, my dear friends. Simply we can see here same thing and getting the 90 is answer. So that is the next question. The question is that a U-tube contains water and methylate spreads separated by mercury. Okay, they are going to be separated by mercury. The mercury column in the two arms are at the same level of 10 cm water in one arm and 12.5 at another speed on other, as shown in the figure. The relative density of the spirit. So first of all you have to be known what is relative density. Once you know the relative density, then only we can proceed next. Now so here I am coming. So see, what is relative density, my dear friends? Relative density is what? Simply we can say, sir, rho of s upon rho w. Both the side we can say here w, na. So rho gh will be same there. From that dot on both sides it should be equal. So rho g h w equal to rho s h s into g. Okay, and you know from there just put that value. Okay, just put that value and by putting that value we will get the answer. Now my dear friends, that is the next question. Question is that three vessels ABC of different shape contains a water up to a same height as shown in the figure. PA, PB and PC be the pressure exerted by the water at the bottom of the vessel PA, PB, PC. So height is same my dear friends. So at a given depth, you know, P equal to rho GH na my dear friends, P equal to rho GH. So if rho G is same, height is same, pressure will be same. Suppose that is the pressure PA, there pressure is PB, here pressure is PC at the bottom, at the bottom. So you know P equal to rho GH, if height is same fluid is there, then obviously pressure will be equally at all the point. So correct answer what will be my dear friends? D for Delhi. Try to remember that not going to depends upon the shape, that just going depends upon the depth. Rho G, fluid should be same, height is same, obviously pressure will be the same at that point. So these three we have seen different shape contains water up to the same height. So height is same. So PA, PB be the pressure exerted water at the bottom of the vessel. So ABC respectively. So you can say the OR will be the equal because P equal to rho G as from the hydrostatics law of fluids, hydrostatics law, and from that you know P equal to rho GH. By using that concept we will get the answer. So same thing is there. Next question, which of the following instrument used to measuring the gauge pressure? Thermometer, barometer, manometer, or you can say the hydrometer. So which of the following instrument used to measuring the gauge? What do you mean by gauge pressure my dear friends? The pressure, the basically manometer in which datum is taken as atmospheric pressure is taken as a datum, then it is called what? Gauge pressure. We can say the if datum you have taken atmospheric pressure, suppose that is absolute 0, this is absolute 0, okay, that is atmospheric pressure, this is PATM, okay. Suppose you have to measure the pressure there, so with respect to that then it is called absolute. If you take base or datum as absolute 0, then it is called absolute pressure. But someone can take datum here now, someone can take it is a datum, then it is called P gauge, okay. Whenever you are taking the datum, even if you have to measure the pressure here, so this is called absolute pressure, but that one is called gauge pressure with respect to the atmospheric pressure, okay. And the gauge pressure you are going to use the manometer. So correct answer is what? A thermometer is going to use for the measurement of temperature, you know, barometer for the pressure measure, especially atmospheric pressure or local atmospheric pressure, we can say more precisely. Hydrometer, relative density, we can say the specific gravity of fluid. By that hydrometer is going to use for the measure of a specific gravity of fluid. In the fluid I will teach you that thing, so don't worry. Try to remember all these: thermocouple, temperature measurement, thermometer, barometer, local atmospheric pressure, that is gauge pressure, hydrometer for the specific gravity of the liquid you have to measure, then you have to use the hydrometer, or more precise we can say fluid of the. So now let us take that question. So what is this? In the old age, arteries carrying blood in the human body becomes narrow, resulting in increase in the blood pressure. This follow from Pascal law, Stokes law, Bernoulli principle and Archimedes principle. So you know what is happening here, we can see there that human body becomes narrow, resulting the increase in the blood pressure, right? So if you have remember the Bernoulli equation, so simply we can say, sir, a Bernoulli equation you can write like that: P upon rho G, P upon rho G plus V square, P square plus V square, or we can say Z equal to something constant. Yeah, in some other sense we can also say it like that. Here in another form you can also give it like that. Here we can say P plus half rho V square is equal to what? Constant. As you know, as the here we can say velocity decreases because sum will be the constant, so another term that must have to be increases. So pressure is increased, that's why in that case blood pressure will what? Increases, simply because you know velocity decreases now because of narrow section, so the pressure is increases. Simply we can remember that thing. So this works on the principle of what? Bernoulli equation. Next question, application of Bernoulli theorem can be seen in dynamic lift of aeroplane, hydraulic press, helicopter, or none of these. You my dear friends, application of Bernoulli theorem, okay. If you talk about hydraulic press, in case of hydraulic press, which principle is applicable? So obviously we can say, sir, here basically going to be work of the Pascal law. In the last you have seen the previous question we have discussed about the Pascal law. So hydraulic press, hydraulic ram, hydraulic jet, that all are working on the principle of Pascal law. But here we think about the Bernoulli equation. So on the basis of Bernoulli equation, dynamic lift of aeroplane takes place. What is happening? Suppose this is the wings. So at the upper part, velocity remains higher. So at the upper part of the wings, if velocity is higher, so you know now P plus half rho v square is equal to constant. So if velocity is higher at the upper part of the wings, so what is happening? Pressure decreases. Now if velocity increases, pressure decreases. And you know at the lower part, since velocity is less, okay, so pressure will be the high at the lower part of the wings, and that's why your aeroplane is going to be lift. So this is working on the principle of what? Simply we can say Bernoulli equation. Even you might have seen that whenever aeroplane is going to be take off, so it take some velocity going to be run on a track approximate 3 to 4 kilometers. During that, what is happening at the wings upper part, velocity higher, so that pressure will decreases, and then the lower part of the wings velocity increases due to that pressure velocity is what here we can say the decreases, so pressure is what increases, and your aeroplane is going to be take off. So this is working on the principle of what? Bernoulli equation. So we can say A is the right answer. Here you can see now the space of the aeroplane wings in such that when it moves forward, the air molecules at the top of the wings have greater velocity relative to the wings and compared to the air molecules at the bottom. Therefore, in accordance with the Bernoulli principle, the pressure at the top of the wings is less than that of the bottom, and pressure difference is created now. At the bottom pressure is higher and the upper part is less, so it is going to be take off. So resulting dynamic lift of the wings which balance the weight of the plane. So try to remember that question, you will find in the exam. Very important concept is there. So that is the next question. Okay, let us zoom out that one. Visible now. So what is that question? A liquid flow through a horizontal tube. That horizontal tube is given in the question as shown in the figure. The velocity in the liquid in the two sections which have area of cross sectional A1 and A2. That even the cross sectional area A1, and here cross sectional area is A2 at the lower part, and yes, corresponding velocities V1 and V2 is given there. So the difference in the level of the liquid into vertical tube is h. The difference between these two is given in the question, and this is h. Then which of the following option is correct? Option A, you can see Vt square minus Vn square equal to 2gh, and option B, and yes, option C and D is like that. So my dear friends, in that case just do one thing, because Bernoulli equation we can applicable. So at the point 1, at the point 2, just apply the Bernoulli equation, and by the using of Bernoulli equation we will get the relation between the velocity and h. So I have came with the solution. See there. So we can say, sir, rho is the density of liquid of the following. So whenever you are going to use the Bernoulli equation we can use only when the flow is steady. If flow is not steady, you cannot apply the Bernoulli equation. Whenever you are going to use the Bernoulli equation, by default the flow is steady there. So if the flow is steady, so we can say, sir, A1 V1 is equal to what? A2 V2. Okay, more precise is what? Rho 1 and rho 2. But since you are talking about the Bernoulli equation, and Bernoulli equation is only used for the incompressible flow. In the compressible flow you cannot use the Bernoulli equation. So rho 1 and rho 2 is going to be cancelled out. So your continuity equation is just coming out to be A1 V1 equal to A2 V2. Okay, from that now use the Bernoulli equation between point 1 and 2. So P1 plus half rho V1 square equal to P2 plus half rho V square, and take pressure one side and velocity another side. So P1 minus P2, that relation. And P1 minus P2 can you write rho GH, pressure difference, pressure difference what you can write? Rho GH. If you talk about delta P, we can write rho G and delta H. So in the delta H is what? H is there. So simply we can write rho G delta H. What is change in height here? We can see now. This is that one, this is that one. So changes is what? Only H So that put that value here, and by putting that value rho GH equal to half rho V1 square minus Vt square, P1 minus P2 equal to rho GH. Just put that value and we'll get the answer. V2 square minus V1 square equal to what? 2gh. Okay, 2gh, and here from that we'll get the answer is what? It is coming out to be A for apple is the right answer. So it was easy question. We can do that very easily. Okay, now rho will cancel out from both the side, na? This row will cancel out, na? Okay. Now coming to the next question. Which of the following parameter of any given instant remains same at every point then flow is said to be? Laminar flow, steady flow, turbulent flow and quasi-static flow. So when flow parameter at any instant, at any given instant remains same at every point, then that flow is known as what, my dear friends? Steady flow. Like that, suppose this is your container and you have filled water in that, okay, in the height of h, and this is the passage, or same cross section is throughout. So if that height is constant, my dear friends, if that height is constant, so what will be here velocity? You can say, sir, velocity will be root under 2gh from the Bernoulli equation, you know na. And once h is constant, so suppose if their velocity is here t equal to 5 seconds, the velocity is 10 meter per second, let us assume. So any time if you see after t equal to 10 seconds, velocity still remains 10 meter per second, because h is not going to be changed, so velocity will not going to be changed. Simply we can say after 1 hour if you are going to be see, again the velocity will be only 10 meter per second at a given point, given cross section. Here property is not going to be changed with respect to time, and that type of flow is known as what? Steady flow or steady state. So we can say B for Bombay is the right answer, steady flow. Okay, just I want to ask one question here. Suppose that is one of the container in which the fluid is filled like that, and the height is what? h. Now that time the passage is something like that, that is in the diverging section, right? Not a uniform cross section, the cross section is different. So can you tell me, is this flow will be a steady or not? Is this flow will be a steady or not, my dear friends? Make a comment. Yes sir, it will be again steady, because in the steady the main thing is what? You have to be see the at a given point, at a given cross section. So if you take that cross section, suppose if you are going to be take that cross section, and their velocity is, let's assume 20 meter per second, let's assume. So at that cross section, at that point, always it will be the 20 meter per second, because h is a constant, h is not going to be changed, so always it will be the 20 meter itself. Yeah, at different point it could be 15 meter per second, it could be, but for always at that point that will be always, because h is constant. But yes, if h will be not constant, then flow will be the unsteady. So here we can say the flow is what, my dear friends? Steady, and hopefully you have given the correct answer, steady state. With increase in temperature, viscosity of, if you are going to increase the temperature, then what will be viscosity? Option A, liquid increases and gas decreases, liquid decreases and gas increases, both liquid and gas increases, both liquid and gas decreases. With increase in temperature of viscosity, you know, if you talk about cause of viscosity in liquid, what is cause of viscosity in liquid? Is cohesion force, na? Cohesion force. Cause of viscosity in liquid, cause of viscosity in liquid is what, my dear friends? So we can say, sir, cohesion force, na? Cohesion force, right? If you are going to increase the temperature, so what is happening? Molecules goes far and far, and in that case, by increase in temperature, we can say, sir, cohesion force decreases, right? Cohesion force is what? It will be decreases. Okay, so once cohesion force decreases, viscosity will decreases. So in case of liquid, viscosity decreases, but if you talk about gas, what is the main cause of the viscosity in the gas? Molecular momentum transfer, right? Molecular momentum transfer. Once you increase the temperature, molecular momentum transfer or molecular collision increases, so the viscosity will increases in case of gas. So simply we can say, sir, in liquid decreases and gas increases. So which one is the right answer? B for Bombay. Try to be remember the cause. In liquid, viscosity is mainly because of cohesion. In case of gas, viscosity is mainly because of molecular momentum transfer. Molecular momentum transfer, or sometimes it is also known as molecular collision, because you know na, if they collide na, they will transfer some momentum, right? This is the one of the molecule, that is another molecules. So once they collide, they will transfer the momentum. That's why it is said that molecular momentum transfer. In some book it is written molecular collision. Both are the same. Once you increase the temperature, obviously the number of collision increases, number of collision increases, and during collision the losses will be also there. So viscosity will increases in case of gas. So by increasing temperature, molecular momentum transfer increases and viscosity is also increases. Here we can see there, gas, in case of gas it increases. Can I want to give one question to you, and that question, do you know what is that question? That question is that, my dear friends, suppose I am talking about the kinematic viscosity. If I increase the temperature, what will be the kinematic viscosity? Increase, decrease, or remain same? Make a comment. What will be the change in the kinematic viscosity? By increase in temperature. Obviously I talk about the liquid. I am going to talk about the liquid. Okay, then you have to be answered. Give the answer, comment fast. Okay, coming to the next question. Next question is that when cooking oil is heated in a frying pan, the oil moves around the pan more easily when it is hot. The main reason for this that with rise in temperature there is decrease in what? Density, surface tension, viscosity or angle of contact. You know my dear friends, and you might have seen that thing in your real practical life. Suppose that is one of the container, right, and that is the base of the container. Okay, just put that in over the gas or you can say stove, whatever, or induction, whatever. Now because my dear friends, what is happening, you are going to be give here cooking oil or mustard oil. You are going to be putting here mustard oil, like, okay, so this is the mustard oil you are going to be put there. So initially what is happening, mustard oil have less temperature, right? So temperature is less, so viscosity will be high, so viscosity resists the flow, right? Viscosity resists the flow. But once it is coming on that surface, so since here gas, stove or induction is there, so temperature of that portion is high. Once the this cooking oil is coming over that, so their temperature increases. Now once their temperature increases, again cohesion force decreases, viscosity decreases. So what is happening, that comes over here. So due to the rise in temperature, that you can say the cohesion force of the simply a cooking oil is what? Decreases and viscosity decreases. So main cause is that by the increase in temperature viscosity decreases. That's why it's easily flow or it is easily wet all the part of that one. So correct answer will be what? C for Chennai. And you can see it in your real life. If when you are cooking, do one thing, put the oil, they will not completely wet that part. Start heating, we will see they will fill whole that part, they will wet whole that bottom part. Why? Because by increase in temperature viscosity decreases, so flow will takes place easily. That's why you are going to be seen. So try to be remember that question, easy question it was. Coming to the next question. Next question is the ratio of inertial force to viscous force represent Magnus effect, Reynolds number, torsional law and relative density. If you talk about Reynolds number, if you have remember, so inertia force upon viscous force, ratio of inertia force Fi upon Fv, this is known as what, my dear friends? Reynolds number. With the help of Reynolds number you are going to be judged either flow is laminar or turbulent, which on the basis of what you are going to be judged. So simply we can say, sir, on the basis of Reynolds number I can judge either flow is laminar or turbulent. Na? So here inertia force upon viscous force is known as Reynolds number. Okay, next question. The raindrop are spherical shape due to viscosity, surface tension, thrust on the drop, or both A and B. Whenever falling drop is there in the raining season, you might have seen falling drop gets converted in the spherical shape. What is the main cause? What is the main cause? The main cause is the surface tension. My dear friends, in the world that is very naturally occurring, everything is tried to be remain in the natural condition. If I will ask, do you want to be in the tension? Obviously we can say no, sir. No one is want to be naturally in the tension state. That's why whenever water is following now, so to reduce their surface tension, they gets converted in the spherical shape. And for a given volume, the minimum surface area is possible in the sphere. That's why it is going to take the spherical shape, raining drops. So try to be remember that point, that raindrop in a spherical generally because of what? Surface tension. So B for Mumbai is the right answer. Viscosity is no role is there, so don't go with the option D. Right. Next question, which of the following statement is not true about the surface tension? Not true. Listen the question, not true about the surface tension. That thing is going to be asked, right? Not true. Not true about the surface tension. A small liquid drop takes a spherical shape due to surface tension. Yeah, that is right, but you have to be choose the wrong statement. So that cannot be answer. Surface tension of liquid is a molecular phenomena. Surface tension of liquid is a molecular phenomena. So B and C is repeated. Okay. Surface tension of liquid depends on the length but not on the area. So what could be the answer? Wrong. You have to be choose wrong option na. So here B and C. Surface tension of liquid is a molecular phenomenon. No, surface tension is basically due to the cohesion and adhesion force. Cohesion force is the force of attraction between the, or you can say among the like particles. If you talk about cohesion is the force of attraction between the like particles. Adhesion is the force of attraction between the unlike particles. No? So basically surface tension is due to the cohesion and adhesion, not because of molecular momentum. But yeah, here since B and C has same, so no problem, either you can go with the option B or C both, but yes, it could be different option. But surface tension liquid is not a molecular phenomena. It is basically mainly due to the adhesion force, mainly due to the cohesion force, but there is some role of adhesion also in the surface tension. So we can say surface tension is mainly, or you can surface tension is basically due to the adhesion as well as cohesion, not a molecular phenomena. Mercury does not weight a glass. This property of liquid is known as, mercury does not weight the glass. This is the property of mercury is known as adhesion, surface tension, viscosity or compressibility. My dear friends, why anything is going to be weight. Suppose if you are going to put the drop of water in your hand, so that water is going to be weight your hand. Why? Suppose this is your hand, my dear friends, and this is the drop of water. So just I have told you that there is two types of force, one is adhesion and another one is cohesion. So adhesion is basically between the unlike particles. Okay, so this is your hand, or you can say any surface, and this is the water droplets or water particles. So at the contact, if you talk about at the contact, at that contact what is happening, adhesion force is going to be act between this object and the water droplets, and here cohesion. So whenever adhesion is more than cohesion, f of adhesion is more than f of cohesion, so that particle will stick or going to be trapped with the solid surface, and it will weight that surface. So when anything is going to be weight only when the adhesion is more than cohesion. Suppose if cohesion will be the higher, so they will try to be keep all the particles simultaneously. Sometimes if you want to be see that whenever cohesion will be high, it will not say the weighting phenomena. Take the wax, mombatti, take the mombatti or mom, over that if you are going to put the water, it is not going to be weight. Why? Because here cohesion is stronger than that of adhesion. So mercury does not weight the glass. So this property is due to what, my dear friends? We can say adhesion. So this will be because of what? They have low adhesion, that's why it is not going to be weight that surface. So A is the right answer. Coming to the next question. When drop of water split up in the number of tiny drops, then surface tension increases, volume increases, energy is absorbed, both and C. When the drop of water is split off into the number of tiny drops, then surface area increases as well as energy absorbed will also increase, my dear friends. When suppose this is the one of the water droplets, if you are going to be convert in the various tiny particles, so first surface area increases and energy is going to absorb, it will also increase. So correct answer will be A and C. That means we can say sir D is the right answer. When drop split up in the number of tiny drops, then surface area increases, volume remains constant. In this process energy is absorbed. Okay, as I have told you, if you are going to be increase the surface area of liquid particles, you have to be give the extra energy, then only we can increase their surface area. Because to reduce the surface tension, water droplets will try to minimize their cross section, we will try to minimize their area. But if you want to increase their area, then you have to give the extra energy that will be absorbed by that liquid. So that is the next question. What is the next question? A capillary tube is taken from the earth to the surface of the moon. Oh, capillary tube is taken from the earth to the surface of the moon. Rise of, this is not the rise, this is rise, okay, RISE. Rise of the liquid column on the moon if the acceleration due to gravity on the earth is 6 times that of moon, on the acceleration due to the gravity, that means g of earth is equal to 6 times g of moon, that relation is given. So a capillary tube is taken from the earth to the surface of the moon, rise of the liquid column, that is rise of the liquid column. So you know my dear friends, what is H? Try to remember that formula. H equal to 2s, or H equal to, sometime you can say 4 sigma cos theta upon rho gd, 4 sigma cos theta upon rho gd. So simply we can say if everything is constant, so H is proportional to 1 upon g, right? Yeah, H is inversely proportional to the acceleration due to the gravity. H is inversely proportional to the acceleration due to the gravity. So you know now. So simply we can say, sir, Hg equal to constant. So from there we will get the relation H of moon equal to 6 times H of earth. H of moon will be the 6 times that of earth now. Right? Okay. So the correct answer will be, see, just H, you can like na, H earth g of earth equal to H moon g of moon. So H of moon will be the 6 times H of earth, because their g is less 6 na, simply we can do that. This is the next question. Which of the following statement is are correct? Okay, each or are correct, right? Temperature is measured the hotness of body. Yeah, that is right now. Temperature measured the hotness of body. So that is right, sir. So A is right. When water boil, its temperature does not change. Yes, during the phase change, my dear friends, in the thermodynamics part we will be taught, or even you might have been taught, that during phase change pressure and temperature is does not going to be changed. So when water boils, temperature does not change. That point is also right. That one is also right. When water boils at room temperature, heat flowing out of it, no. So the correct answer will be what? D for Delhi. D for Delhi. Okay, D for Delhi is the correct answer. Both A and B is the right answer. Temperature measures the hotness of the body, and whenever the phase change takes place, temperature remains constant. Not even temperature, pressure is itself also remains constant during that. So the B is the right answer. Means D, both are the correct. That is the next question. In order that the heat flow from one part of solid to another part, what is required? Uniform density, temperature gradient, density gradient, or uniform temperature? So what could be answer, my dear friends? Tell me. Tell me, my dear friends, what could be the answer? Anybody? So sir, heat will takes place from higher temperature to lower temperature, right? So there must be temperature gradient. Temperature gradient means temperature per unit length. Okay, so for the flowing of heat, temperature gradient should be there, right? For the flow of liquid, there should be pressure gradient. Same thing for the flow of heat, there should be temperature gradient, and heat is flow from high temperature to low temperature. Heat is going to flow from high temperature to low temperature, so there must be what? Temperature gradient. And that is the part of thermodynamics you will be taught, so don't worry. In our live class I will teach you that things. So that is the next question. The temperature which have same numerical value on Celsius and Fahrenheit scale is, try to remember that value. Very frequently that question has been asked in all the exams, so try to remember that one, my dear friends. Here we can see I am coming with that relation. You have to be just keep in mind that degree C upon 100 is equal to F minus 32, F minus 32 upon 180, right? So according to question that have to be same, just do at equal, and after solving we will solve it. Minus 40 degrees Celsius equal to minus 40 Fahrenheit. So you have to remember that question, my dear friends, several times. In the exam you might forget that relation, so better to remember that equation, that one result, that at 40 degrees Celsius is equal to 40 Fahrenheit, minus 40 degrees, sorry, pardon, minus 40 degrees Celsius equal to minus 40 Fahrenheit. In that case both are going to be equal, right? Next question. Molecules of an ideal gas behaves like inelastic rigid sphere, perfectly elastic rigid sphere, inelastic non-rigid sphere, perfectly elastic non-rigid sphere. So molecules of an ideal gas behaves like. If you talk about ideal gas, my dear friends, so what do you mean by ideal gas? Anybody? So molecules of an ideal gas behaves like a perfectly elastic rigid body. This behaves like, okay, and you also know na, ideal gas is not going to be exist now. Yes, air can be treated as an ideal gas because of some property going to be matched with that. So in case of, you can say molecules of an ideal gas behaves like a perfectly elastic rigid sphere. So B for Bombay is the right answer. That is the next question. In the whole of middle of a copper plate, when heating the plate, the diameter of hole will, there is a hole of middle of copper plate. Okay, suppose that is one of the copper plate you have, and there is a hole, right? There is a hole. So once you are going to be heat of that plate, suppose that is the one of the furnace or any gas cylinder, cooker or whatever, you are going to be heat of that one. So what will be that hole? What will be that hole, my dear friends? Anybody can tell me? So obviously by the heating anything is going to be expand, right? If you are going to be heat, it will expand, my dear friends. Yes sir, it will expand. Okay, so once they will expand, the diameter of that ball, diameter of that hole will also increase, my dear friends. Yes, so we can say while heating the plate, the diameter of hole is always increases. So A for apple is the right answer. It is going to be increased. Now suppose this one, so once we heat they will expand, and due to that the hole diameter will also increase it. So always increases. So A is the right answer. That is the next question. What is the next question? The coefficient of volume expansion of a liquid is gamma. The fractional change in density is change in density is delta T, rise in temperature. So rise in temperature, if you talk about, so what is this? Alpha. So sometimes it is going to be alpha, sometimes gamma. So coefficient of volume expansion is what? Gamma. The fractional change in density is given by gamma delta T. Try to be remember in the thermal stress, little bit I will see about that. So gamma delta T directly we can say, if the temperature is raised by delta T, so it will be gamma delta T. Okay, so answer is what? A is the right answer, gamma delta T. Gamma is volume expansion, so density equal to mass upon volume. According to that we will get that one, That is the next question. I am going to be zoom out. Right. Which of the following graph shows the variation of density of water with increase in temperature? That is the question. With increase in temperature, which of the following is that? Shows the correct graph. Give the answer fast. Give fast. Simply we can say, with the which of the following graph shows the variation of density, variation of density, temperature is density is maximum at 4 degrees Celsius, my dear friends. So in all that, so that is the variation, that is not the constant. So correct answer will be the A for apple. Try to remember, density of water is maximum at 4 degrees Celsius, approximate 999 point something, or you can say the 1000 kg per meter cube. That is happening at the 4 degrees Celsius when their density is a maximum, and after 4 degrees Celsius this is going to be decreased, even less or left, right, whatever. If less than 4, again density will be less. Higher than 4 degrees Celsius, again density will be the less. So correct is what? A for apple is the right answer. Next question. Heat capacity of a substance is infinite. It means heat is given out, heat is taken in On change in temperature, whether heat is taken on change in temperature, whatever whether heat is taken in or given out, all of the heat capacity of a substance is infinite. The heat capacity is what? Infinite. So what we can say the correct answer, my dear friends? All. So what could be? Heat capacity of a substance is infinite. It means heat is given out, okay, heat is taken in, okay, on change of temperature, whether heat is taken in or given out. So heat capacity is infinite, so we can say C is the right answer. More precise answer is that C for Chennai is the highest precise answer. The change from solid state to vapor state without passing through a liquid state is called, what is called, my dear friends? The change from solid state to vapor state without passing through the liquid state, this is called the change from solid to vapor directly. No liquid state is going to be takes place. That is known as fusion, regulation, vaporization, or sublimation. Sublimation. So what could be the answer, my dear friends? Yes, we can say the sublimation whenever directly, you know, even Kapoor, if you listen the name of Kapoor, directly it is going to be takes place from the liquid solid to vapor state, so it is called sublimation. You have to match that one, my dear friends. You have to match. Take 1 minute, try to match that one. You can just take 1 minute and try to be answer that one. Do fast. See, A, convert liquid into solid, liquid into solid, liquid into solid, so it will be called fusion. So A will be the R. Conversion of liquid into vapor, so it will be called vaporization, no? So B will be as conversion of solid into vapor directly, solid into vapor directly, sublimation. Melting of ice caused by pressure is, this is called regulation. So just match all that, and by matching, yes, you will get the what, my dear friends? B will get the answer. Visible, na? Visible properly, na? Okay. Next question. Which of the following statement is correct? The triple point of water is 253.16 Kelvin. Burns, okay, correct, na? Burns from steam are less severe than those from the boiling of water. Ethyl alcohol expand less than mercury for the same rise in the temperature. When fully inflated balloon is immersed in cold water, it will contract. Which of the following is the correct? You have to be asked the correct answer. So what will be, my dear friends? Okay, that one is 273.6, 273.16. Okay, so the correct answer A could not be, na? 253 is given. So when fully inflated balloon is immersed in cold water, it will contract. Why? Because heat is going to be fully inflated balloon immersed cold water, so heat is going to be out from the balloon, na? So it will going to be contract. Even you might have seen just one thing. Take a balloon, inflate in, put the air inside during the sunshine, and put in the dark place. After some time, you will find their volume is what? Contracted. Now, the sprinkling of water reduce slightly the temperature of a closed room because temperature of water is less than that of room. A specific heat of water is high. Water has large latent heat of vaporization. Water is bad conductor of heat. So, a sprinkling of water reduce slightly the temperature of the closed room because water has large latent heat of vaporization. They will take the heat, get converted into vapor state. due to that the temperature will decrease of your room. Water reduce slightly because once you are going to splinking the water na, so they will take the heat from your room and it is going to be converted in the vapor state. So they have taken the heat from the room na, so their temperature is decreases. So what? Chennai is the right answer. There is no net flow of heat between two systems when they are in contact. Suppose this is one of the system, this is another system, and these two are in the contact. Okay, these two are in the contact. Still heat is not going to be flow. That means temperature is same na, so it will be thermal equilibrium. When two body, this that is from the zeroth law, this body and this body, I am going to be contact and there is no heat transfer takes place. That means these two body have same temperature. That means thermal, we can say the equilibrium, same temperature is there, then only it is not going to be flow. So A is the right answer. So that is the next question. An electric heater supply heat to a system at the rate of 120 watt. Okay, if the system perform work at the rate of 80 joule per second, then the rate of increase of internal energy. That question has been taken from the thermodynamics. If you know the first law of thermodynamics, so we can say dq equal to du plus dw. Right. So sir, in this it talk about the rate na sir. So do divide dt all that, because in the question it is given in the form of rate. So we can divide all that na. So rate of increase internal energy they are going to be asked. Rest data you have. Huh? So an electric bulb heat supplied to a heat, an electric heater supplied to a heat of 120. So that value is known 120. Perform work at the rate of 80 joule per second. So that one is also known. You have to be calculate the du upon dt. So here we can say I have used that equation, and by solving that we will get the equation how much it is coming out to be 40 joule per second, right. So 120, this is given 120, this is 80, so it will be 120 minus 80, this is 120 minus 80, and we will get the answer how much, 40 joule per second. It was an easy question. Now that is the next question. The PV diagram is shown, right. What? PV diagram. The PV diagram shows expansion of a gas. Which one of the following statement is true? A is isothermal, B is adiabatic. A is adiabatic, B is isothermal. Both are isothermal, both are adiabatic. You know my difference. You have to be judged on the basis of slope. So if I will ask which one have more slope, if you talk about TPCB, here we can say slope of B is more than slope of A. Therefore curve A is isothermal and B is what? Adiabatic process. Try to be remember here simply. A is isothermal, B is adiabatic. A is what? Isothermal and B is what? Adiabatic. So adiabatic have more slope. Even we can check na. If you see, so that and that have more slope. So beta is adiabatic, they are more slope. Gamma times of, you know, if you have remember, slope of adiabatic is gamma times of slope of isothermal. Slope of adiabatic curve, thermodynamic part, is equal to gamma times slope of isothermal. So try to be remember. That question has been taken from the thermodynamics. Next question. A cycle tire burst suddenly. What is the type of this process? Isochoric, isothermal, isobaric, or adiabatic? So cycle tire burst. You might have seen in the summer session now. Cycle tire or sometimes your bike tire also going to be burst suddenly. So this type of process is what? Isochoric, isobaric, or isobaric, adiabatic, or isothermal. What we can say here? Sudden na. So sudden will be what? Adiabatic. Why? In case of adiabatic, no heat transfer takes place. Why? Because tire burst suddenly, so they don't have sufficient time to transfer the heat. And heat is energy transfer by because of temperature difference. So suddenly, due to the suddenly burst, there is no sufficient time to transfer the heat. That's why it is called is what? Adiabatic process. So the correct answer is what, my dear friends? D for Delhi is the correct answer. This is what? Adiabatic process. Okay, my dear friends. So that all are about my part. After that, now Bini sir will come and they will see the rest question of their respective part. Okay, we will meet in the some next session, and you know our module is also going on, so we can join our paid batch where you know we can join all that subject, we can read in the details and we can join that one. Okay, so after that Bini sir will deal with you. Okay, my dear friends.
Hello everyone. So first half of the question has been done by the Rajiv sir here, and the remaining question I am going to cover it down. So let us start with the questions here. So here you can see the first question is the dimension of A and B in the relation F is equal to AX plus BT R. Okay, so this question is related to the basic dimensional analysis here. Okay, so in this case we have been provided with the relationship. You can see F is equal to AX plus BT. Okay, so now you can see we have to find out the dimensions of A by B here. Okay, so in this case you can see first of all, on the left hand side we have a force, and force is having a dimensional units of the mLT minus 2. That simply means the dimensions of AX, the dimension of AX as well as the dimension of BT, both has to be equal to mLT minus 2 here. Why so? Because the only the term which are having the same unit can be added with each other, or I can say the term which are having the same unit can be added or subtracted from each other here. Okay, so I can say the product of AX is going to have a same unit of the F here, and as well as the product of B into T is going to have a same unit as the force here. Okay, so in this case you can see A is going to be equal to F by X, and the dimensional unit of F is going to be equal to mLT minus 2, and X is generally the displacement here. So I can say the dimension unit here is L. Okay, so here you are going to see that the dimensional unit of the A is going to be equal to MT minus 2 here, and similarly if you see about the B part, the B is going to be equal to F by T. Okay, B is having a unit of the F by T here. So again F is mLT minus 2 and T is capital T. So if you simplify it further, you are going to get the dimension unit as mLT minus 3 here. Okay, this unit you are going to get. So now I can say the ratio of the A and B is going to have a unit of. So always remember, it is not necessary that while doing the multiplication or a division the units has to be same here. They may be different here. Okay, so in this case I can write A is MT minus 2 and B is mLT minus 3 here, and if I simplify it further, you are going to get L minus 1 T plus 1 here. Okay, so this is the final unit of the A by B here. So I can say the option number B is going to be the correct answer of this particular question. Okay, so this question is very simple. So always remember, the question which has been framed from this particular topic, dimensional analysis, the question is going to be very simple here. Okay, now let's move to our next part here. In the next question you can we can see momentum per unit volume has the dimension of. So now in this case again we have to find out the dimensions of the momentum per unit volume here. Now what is the meaning of momentum actually? Momentum is defined as the product of the mass into velocity here. Okay, and it tells you about how much quantity of motion the body has been possessed here. Okay, momentum per unit volume. So I can say the momentum is having a unit of mass into velocity. So mass is m and velocity is lt minus 1. So this is the dimensions of the momentum here, and similarly for the volume we are having the dimensions of L cube, that is meter cube here. Okay, and if you simplify it further, you are going to see the momentum per unit volume has the dimensions of ml minus 2 t minus 1 here. Okay, so I can say the option number C is going to be the correct answer of this particular part here. Okay, now the next question is, two resistance are expressed as R1 is going to equal to 4 plus minus 0.4 ohm and R2 is equal to 12 plus minus 0.4 ohm here. So what is the absolute error in the net resistance when they are connected in series here? So now always see, whenever you are finding, whenever you are doing the question related to the error here, okay, the questions are going to be very simple here, okay. And specifically whenever you are dealing with the errors in the resistance, you have to make ensure that whether the resistance are connected in the series or in the parallel here, okay, because whenever the resistance are connected in series, I can say the total resistance will be equal to R1 plus R2 here, okay. Similarly, if you just calculate the value of the error associated in the total resistance, it will be equal to delta R upon R equal to delta R1 upon R1 here, okay, plus delta R2 by R2. So this expression is written in the form of percentage here, okay. And similarly, let us say if the resistance are connected in parallel, I can say the total resistance is going to be equal to 1 by R total is equal to 1 by R1 plus 1 by R2 here, okay. So in this case, if you find out the value of the resistance associated, sorry, if you just calculate the value of the error associated with the total resistance, it will be equal to delta RT is going to be equal to delta R1 by R1 square multiply by RT here, plus similarly delta R2 by R2 square into delta R2 here, okay. So this is the expression you are going to see here. So in this case, the resistance are connected in series, so I can say the total resistance, so total error induced in the total resistance will be equal to delta R1 plus delta R2 here. So now you can see the error induced in the R1 is 0.5, and similarly the error induced in the resistance R2 is again 0.5. So therefore the total error induced will be 1 ohm here, okay. So option number A is going to be the correct answer in this case here, okay. So again a question is very simple. Now the next part, the errors in the measurement of the mass and velocity of a moving body are 2% and 3% respectively. Error in kinetic energy obtained by measuring mass and speed will be. So now just say in this case, first of all we know that error in the mass delta m by m is given to you as 2%, and similarly I can write delta v by v equal to 3%, okay. And what you have to calculate, you have to calculate the value of the error induced in the kinetic energy, and the formula of the kinetic energy is half mv square here, okay. So in this case I can write delta ke divided by ke is going to be equal to delta m plus 2 delta v by v here, okay. So I can say the delta m by m is given to you as 2% plus delta v by v is given to you as 3%, and if you solve it, you are going to get the total error induced in the kinetic energy as 8% here, okay. So option number C is going to be the correct answer here. Next part, given that the time period of a soap bubble depend upon its radius, density, surface tension, etc., the dimensionally correct relationship will be, okay. So now in this case the time period is given to you. So first of all, the time period is having a dimensions of t, radius is nothing but it is the length here, and density is mass per unit volume, so I can write ml minus 3 here, okay, ml minus 3. And surface tension is basically the force per unit length, okay. So I can write it is equal to mt minus 2, force per unit length here, mlt minus 2 divided by L, so basically mt minus 2 here. So now here you can see, we know that the time period t is basically a function of radius, density is denoted by here rho, sigma, as well as the surface tension, which is denoted by T here, okay. So in this case I can write that small t is having a dimensions of m0 L0 t minus 1, m0 L0 t1 here, and similarly r is having a dimensions of L here, okay. And we don't know that time period is basically depending upon linearly with the radius, or it is varying parabolically, okay, cubically, I don't know. So that is why I am just taking the power as a here, because we don't know the exact value right now. Similarly, the density ml minus 3, again we don't know the exact relationship between the time period and the density, so I can say ml minus 3 to the power b here, and surface tension is mt minus 2 to the power c here. Okay, so you are going to get this final expression. So if I just compare the unit of m, l and t here, so first of all let me simplify it further. You are going to get m to the power b plus c, L to the power a minus 3b, and t to the power minus 2c here. So if I just compare the power of m, l and t, you are going to see that b plus c is equal to 0. B plus c is equal to 0. That simply means b is going to be equal to minus of c. Okay, next part, a minus 3b is going to be 0. So I can tell a is equal to 3b here. Okay, a is equal to 3b. Let me check one more time. L, b plus c, a minus 3b, yes, minus 2c. That is, everything is okay now. Now in this case, again, if you can see, t is having a power of 1 here, and on the right hand side we have a t to the power of minus 2c here. Okay, so from here I can say the c is having a value of minus 1 by 2. C is having a value of minus 1 by 2, and if I just put the value of c in this first expression in equation number a, you are going to observe that b is coming out to be as 1 by 2. Okay, and if I just put the value of b in the equation number b, so you are going to get a is equal to 3 by 2 here. So I can write that how the time period is depending upon the radius, density and the surface tension as. So I can write time period is depending upon the radius to the power here is r is having a power of a. So I can say r to the power 3 by 2. Density is having a power of b here, so I can say it will be equal to 1 by 2 again. And in the last, surface tension, it is basically having a power of minus 1 by 2 here. So if you just compare the options, so I can say the option number b is coming out to be the correct answer here. Okay, time period is depending upon r to the power 3 by 2, sigma to the power 1 by 2 and t to the power minus 1 by 2 here. Okay, so option number b is going to be the correct answer in this case here. Now the next part is the dimension formula of the pressure gradient. Now what is the meaning of pressure gradient? Basically the pressure gradient tells you that how the pressure change is there along the vertical distance here. Okay, so I can say dp by dx, whether if you are just defining the change in pressure with respect to the vertical distance or the horizontal distance, it is nothing but it is the pressure gradient only. So dp by dx is basically the pressure gradient. Okay, so now in this case, what is the meaning of pressure? Pressure is defined as the normal force per unit area. So I can say the pressure is having a unit of force per unit area, and dx is representing the displacement here. So I can write it is x here. So if I just put the values of the unit, so f is having a unit of mlt minus 2, area is having a unit of l square, and x is having a unit of l here. Okay, so if I just find out the dimensions, so dimensions of the pressure gradient will be ml minus 2, t minus 2 here. Okay, so in this case the option number d is going to be the correct answer here. Okay, so again the question is very simple. Now the next part, the potential energy of the particle varies with the distance x from the fixed origin as a to the power a under root x divided by x plus b here, where a and b are constant, and we have to find out the dimensions of a multiply b here. Okay, we have to find out the dimensions of a multiply b here. So first of all, just see, if you just see this expression, in that case I can say the dimensions of the b and x are going to be remain same, because these two quantities are adding with each other here. Okay, and similarly I can say, okay, first of all x is given to us, x is the distance here, so I can say the b is having a unit of l, b is having a unit of l only, because x is having a unit of l here. Okay, so I can write the unit of B will be L here. Okay, the first thing is clear. Now what is V? V is representing the potential energy. And what is potential energy? Potential energy is nothing but it is the force into distance here. So I can say V is having a unit of force multiplied by distance. Okay, so I can say force is nothing but it is equal to ml t minus 2, mass into acceleration. X is distance here. Okay, so I can say the potential energy is having a unit of ml2 t minus 2 here. ml2 t minus 2 here. And in this case, in the denominator we have a unit of L here. We have a dimensions of L here. A we don't know. We don't know the unit dimensions of the A here. We don't know the dimensions of the A here. So I can write simply A. Under root of x is having a dimensions of meter to the power 1 by 2 here. So I can say it will be having a dimensions of L 1 by 2. Okay. So if I just find out the value of A, the dimensions of the A here, from this particular equation I can write ml2 t minus 2 multiply by L divided by L 1 by 2 here. You are going to see this expression here. Okay. So in this case I can write m L 5 by 2 t minus 2 here. You are going to see this particular expression here. Okay, just solve it and you will get your final answer here. So I can say the option number A is going to be the correct answer of this particular part here. Okay, so again a question is very simple here. Now the next part is ml2. Yes, option number A is basically the correct one here. Okay, just wait a minute, let me re-verify it once. So here we have a potential energy ml2 t minus 2 A under root of L here, and here in the denominator we have a L here. Okay, so in the L1 minus 2 here, L1 minus 2. Yes, option number A is going to be the correct answer only here. Yes, oh sorry, A is the correct one. A is having the dimensions of ml 5 by 2 t to the power minus 2, but in this case we have to find out the units of A multiplied by B. Okay, we have to find out the dimensions of A multiplied by B here. So I can write ml 5 by 2 t minus 2 multiply by L here. Okay, so if you just multiply it, you will get the dimensions of ml 7 by 2 t minus 2. So this is the dimensions of A by B, A multiplied by B here. Okay, so option number D will be the correct answer. Okay, option number D will be the correct answer in this case. Now the next part, the error occurred due to the imperfection of the observer, improper instrument. So that's a very simple case. You can see error can be occurred due to the imperfection of the observer here. Okay, that is why the skills of the observer is very necessary. Second, improper instrument, if you are using, if the instrument is not properly calibrated, in that case you are going to get you are going to see a very large value of the error here. Okay, so option number C, both A and B will be correct in this case. Next, time period measured by a simple pendulum is 4 seconds. 4 students measure the value separately. Which student is more accurate and precise? These values measured by the students are: student A is having a value of 4.02, student B is having a value of 4.001, student C is having a value of 3.982, student D is having a value of 4.12. Okay, so I don't think this question need any explanation here, because you can see the value of the student B is very close to the exact value here. Okay, the measured value is very close to the true value, and correspondingly the error induced, if you just calculate the error in all of these cases here, the error is basically 0.001 in this case here. So I can write the student number B is having a very I can say it is having a accurate and precise value, okay, as compared to the remaining students here. Now the next part is, a stone is released from the tower. A stone is released from the top of tower. So let us say we have a tower like this one. So a stone is dropped from this particular height here. So you can see, let us say it is having a height of capital H. If its velocity at half of the height is 10 meter per second here, then height of the tower will be, okay. So here in this case we know that the value of the velocity at this particular point B is equal to 10 meter per second here, 10 meter per second here, okay. In that case, what will be the height of the tower here? So now just see, in this question you have to use this simple Newton's law of motion here, okay. Question is very simple again, there is nothing to do in this part here. In this case you can simply write we want to find out the value of the, you can simply write V square is equal to U square plus 2AS. We know this expression here, because whenever the stone is dropped from the top of the tower here, the acceleration is going to be uniform here, okay. Its value is going to be equal to the gravity here. So I can write the initial velocity is going to be equal to 0. So therefore the velocity at the top of the tower, it is not at the top of the tower, the velocity at the bottom is going to be given as under root of 2gh here. Now in this case we know the value of the velocity at point number B. So I can write velocity at B. So can I say that at particular point B, the height covered by the stone, it will be equal to h by 2, okay. So you can write 2g h by 2 under root here, and if you solve it further you are going to see that Vb is equal to root 2g capital H divided by root 2 here, okay. And we know, okay, what do we want to find out here? We want to find out the value of the h here now, okay. Just put all the values here in this expression. So value of the velocity is given to you as 10 here, correspondingly gravity is given to you as 10 here, height we have to calculate, okay. So if you just simplify it further, you are going to see that h is coming out to be as 10 meter only, okay. H is coming out to be as 10 meter here. So in this case the option number B is going to be the correct answer. So again a very simple question. Now the next part, when two particles each of mass m are dropped from a height h and it is h by 2, I think it is h by 2 here, yeah, no sorry, it is 2h here, it is 2h here. When two particles each of mass m are dropped from a height of h and 2h respectively, so one particle is dropped from this particular point A and the another particle is dropped from the point number B here, and you can see the height of the A point is small h and the height of B point is 2h here. Then in this case the ratio of their time to reach the ground is asked basically, okay. So in this case if you see, according to the Newton law of motion, we know that S is equal to ut plus half at square. We know this expression, and in this case basically when the stone is when the particle is dropped, actually it is moving with the moving with the constant acceleration here, that is gravity. So I can write the first term is going to be 0, okay. So I can write that time will be equal to 2s divided by a under root. So this will be the time, okay. So what do you want to find out? You want to find out the ratio of their time to reach the ground here. So I can say the ratio T1 by T2 is going to be equal to, so now just see, the particle is dropped from point number A and it is covering a distance of h here. So it will be equal to 2h by g, and similarly the particle B is dropped from the 2h here. So I can write 2h divided by g here. And if you just simplify it further, you are going to see T1 by T2 is coming out to be as 1 by under root 2, okay. So option number C is going to be the correct answer in this case here, okay. So again the question is very simple, but it is a little bit tricky also. Now the next part, A body moves along a straight line and its displacement at any time is given by s is equal to t cube minus 6t square plus 3t plus 4 here. What will be the velocity of the body when its acceleration is 0 here? Okay. So in this case, first of all, you have to calculate the expression of the velocity as well as you need to calculate the expression of the acceleration also. Okay, and you have to find out the time at which the acceleration is 0. Okay, and at that particular point of time, you have to calculate the velocity of the object here. Okay, so first of all, let us calculate the velocity here. So velocity is nothing but it is the differentiation of the displacement with respect to time here, ds by dt. So I can simply write the differentiation will be 3t square minus 12t plus 3 here. And if you just calculate the value of the acceleration, it will be equal to dv by dt. dv by dt is going to be equal to 6t minus 12 here. Okay. Now in this case, the acceleration is going to be 0. Acceleration is going to be 0 at time equal to 2 seconds here. So therefore I can say the velocity at time t equal to 2 seconds, it will be equal to 2 square minus 12 2 plus 3 here. So if you simplify it further, you are going to get 12 minus 24 plus 3, and it's coming out to be as minus 12 plus 3 minus 9 meter per second. Okay, minus 9 meter per second. So therefore the option number A is going to be the correct answer in this case here. Okay, so option number A is going to be the correct answer, that is 9 meter per second here. Okay, now the next part is 120 meter long train is moving toward west at the speed of 10 meter per second. A bird flying toward east at a speed of 5 meter per second here. So you can see a train is moving. Okay, so first of all, just see, here we have a north, here we have a south, here we have a east, and here we have a west. Okay, so now 120 meter train is moving toward the west here and with the velocity of 10 meter per second, and a bird is flying toward east here with a velocity of 5 meter per second here. Now what do we want to find out? We want to calculate that what is the time taken by the bird to cross the train here. Okay, so first of all, just see, in this case that both of these bodies are attaining some velocities here, so that means there we have to use the concept of the relative velocity, and whenever the two bodies are moving toward each other, so in that case the relative velocity, I can say the relative velocity of the bird with respect to train, it will be equal to Vb minus Vt here. Okay, bird velocity is 5 meter and the train velocity is minus 10. So I can say the velocity of the bird with respect to train is going to be equal to 15 meter per second here, and correspondingly the bird is covering a distance of 120 meter here. It has to cross the train now, that is why. So therefore I can say the time taken by the bird to cross the train will be s by velocity displacement by velocity here, so it will be 120 divided by 15 here. Okay, so therefore the time will be equal to 8 second. Time will be equal to 8 second here. Okay, so option number A will be the correct answer. Now the next part is the distance covered by the object in nth second of its motion. So that's a very simple case. In that case you have to use the direct expression here, and the option number B is going to be the correct answer. Okay, so this is basically the expression which is used to calculate the distance covered by the object in the nth second of its motion here. Okay, now next part, a body is thrown vertically upward. It travels 60 km upward, 60 km upward, and returns to the original position here. In that case, what is the displacement of the body here? Okay, so now just see, we have to calculate the value of the displacement. And what is the meaning of displacement? Displacement is a vector quantity. Displacement is the shortest distance between the initial and the final point here. So you can see initial and final points are same here. Okay, so I can write the displacement, the shortest distance between them is 0 only. Okay, so option number C is going to be the correct answer. But let us say if they ask you that what will be the value of the distance here, so here you have to check, you have to just calculate the total length or total path covered by the object here. So first 60 km is covered, then again 60 km is covered here. So I can say 120 km is going to be the distance, 0 is going to be the displacement here. Okay, and if you just calculate the value of the average velocity, again it will come out to be 0. If you calculate the value of the average speed, it will come out to be distance upon time here. Okay. Now the next part, a body thrown upward with some velocity reaches the maximum height of 100 meter. Another body is thrown upward with half the initial velocity. Half the initial velocity will reach a maximum height of, okay, will reach a maximum height of, in this case here. Now in this case, if you see, body is thrown, let us say, from this particular point A with some velocity. Okay, so let me assume that u is the initial velocity here. Now it is moving against the gravity, so I can say the acceleration is going to be equal to minus g. Acceleration is equal to minus g here, and correspondingly the distance covered by the maximum height will be equal to 100 meter here. So now another body is, if it is thrown upward with the initial velocity, with half the initial velocity. So let us say we have another body B, and it is projected in the vertical direction with the velocity of u by 2 here. Then what will be the height here? We have to calculate. So we have to calculate the value of the h here. Okay. So we have to use the Newton law of motion here in this case. So I can write v is going to be equal to u, v square equal to u square plus 2as. Okay, and we know at the maximum height the velocity is going to be 0. Initial velocity is u here, acceleration is minus g, and the distance covered is, let us say it is h here. Oh sorry, it is not h. Let me just put the 100 value only here. So it will be 100 here. Okay, it will be 100 only. Now in this case I can write the u is going to be equal to the u square, or I can say, okay, u is going to be equal to 200 g under root here. Okay, under root of 200 g is going to be the u here in this case. So now we know that the particle B is projected with the half of velocity here. So I can say again the velocity is going to be 0, final velocity. U square is under root of 200 g. This is the u by 2. Okay, square plus 2 gravity, it is not plus, it is minus here, because we are moving against the gravity here. So you are going to get this particular expression. So if you solve it further, if you just solve it further, you are going to get the expression as 200g divided by 4, it is going to be equal to 2gh here. So you can see the answer is coming out to be 25 meter. The maximum height which the particle B achieve, it will be 25 meter here. Okay, so option number D is going to be the correct answer out of these here, out of these options here. Okay, now let us move to our next part. What is the value of the acceleration due to the gravity at the highest point if a body is projected vertically upward? So you can see whenever the body is projected upward, okay, it is moving against the gravity here. Okay, so I can say the acceleration which is acting over the body is going to be equal to minus of gravity here. And once it reaches the, once it reaches the highest point, let us say at point number A, in that case what the body has to do? Body has to move in the downward direction. Okay, body has to move in the downward direction. So always remember, in that case the velocity, the value of the acceleration due to the gravity is going to be remain constant there. Okay, it will be equal to 9.81, but its direction will change here. Now it is acting in the downward direction at the highest point here. Okay, now the next part is, when a particle moves in a circular path, then the direction of the centripetal acceleration is. So in this case, always remember there are two cases in this case. So whether the body is moving in a circular motion with a uniform velocity, or either it is moving in a circular motion with a non-uniform velocity here. So always remember that whenever a body is rotating, there are two acceleration involved in this analysis here. The first one is the radial or the centripetal acceleration, and the second one is the tangential acceleration here. Okay, the first one is the radial or centripetal acceleration here, centripetal acceleration, and second we have a tangential acceleration here. Okay, just always remember that part. And when we talk about the radial and centripetal acceleration, always remember that no matter whether the body is moving with a uniform velocity or a non-uniform velocity, radial acceleration is always going to be there inside the body here, and it is always acting toward the radius here. Okay, it is always acting toward the radius, whether the body is moving with the uniform velocity or it is moving with the non-uniform velocity here. So in this case I can write the magnitude of the radial acceleration, it will be equal to v square by r, or it will be equal to omega square by r here. Okay, and it is toward the center here. And if we talk about the tangential acceleration, so always remember, tangential acceleration is always going to be there when the body is moving with the non-uniform velocity, okay, due to the angular acceleration. But once the body is moving with the uniform velocity, in that case angular acceleration will be 0 and the tangential acceleration will be 0. So I can write the tangential acceleration will be 0 here in this case. Okay, or in the non-uniform motion it is going to have a value of r into alpha here. Okay, now the next part, what is the value of the linear velocity omega if omega is given as 2 I cap minus 4j plus k cap and the radius position vector is given to you as I cap plus j cap plus k cap here. So what do you want to find out? You want to find out the value of the magnitude of the velocity here. So we know that the velocity vector is defined as the cross product of angular velocity multiplied by the position vector. Okay, and if you just put all the values here, so here we have to perform the cross product. So I can write I, j, k, and omega is having a value of 2, minus 4, 1, r is having a value of 1, 1 and 1 here. Okay, so just simplified further, I cap, we are going to see minus 4, minus 1 here, plus j, okay, or let me write minus j here, minus j, you are going to get 2 minus 1 here, plus k, 2 minus 4 here. Okay, so I can say the velocity vector, either we have to use we have to find out the magnitude of the velocity vector here. So it will be minus 5i minus j plus 6k cap here. Okay, so which option is correct here? Option number B. Option number B is the correct expression of the velocity vector here in this case here. Okay, so again a question is very simple. Now the next part, in what direction should a boy at rest? Should a boy at rest hold his umbrella? So basically the boy is here, which is at the rest position. If the rains fall vertically with the speed of 30 meter per second. So here the rain is falling here with a speed of 30 meter per second, and correspondingly the wind blows toward the west here, toward the west. So we know here we have a north, here we have a south, here we have a east, and here we have a west. So I can say the wind is moving toward the west here with the magnitude of 10 meter per second. Okay, in what direction the boy have to hold the umbrella here? So can I say that when the wind is flowing toward west, the final direction of the rainfall, it is going to be something like that here. So this will be the direction of rainfall. It is the rainfall is falling toward the southwest direction here. So in order to balance it, the person has to hold the umbrella like this one here. Person has to hold the umbrella like this one here. Okay, so we can say the person has to hold the umbrella. Okay, from the vertical we have to see. So here you can see. So this is our vertical. Okay, so from the vertical, in which direction it has to hold here? So it has to hold toward east here. So basically it is holding toward east from the vertical here. Okay, so I can say that out of the option number B and D is going to be the correct answer here. Okay, out of the option number B and D, it is going to be the correct one. Now we have to find out the value of the angle, at which angle it has to hold. So now you can say velocity, downward velocity is 30, and here we have a 10 meter velocity. Okay, and we have to calculate this particular angle. Can I say that tan of alpha is going to be equal to 10 by 30 here? So therefore I can say the alpha is going to be equal to tan of inverse 1 by 3 here. Okay, so I can say option number D, tan of inverse 1 by 3 toward east from the vertical, the person has to hold the umbrella here. Okay, so option number D will be the correct answer. Now the next part, if a unit vector is represented by 0.5 I cap plus 0.8 j cap plus c cap ck, then what will be the value of c here? So in this case you can see the magnitude of the unit vector is 1 here. So I can write 0.5 square plus 0.8 square plus c square. It is going to be equal to 1 here. So if you solve it further, you are going to get c square, it will be equal to 1 minus 0.25 minus 0.64 here, and the value of c will be 0 under root of 0.1 over here. Okay, so option number B is going to be the correct answer here in this case. Next question, if A is equal to if A is equal to I cap plus 2j cap plus k cap, and B is equal to 2i plus 3k, C is equal to minus 2i cap plus 4k cap, then what will be the magnitude of A plus B minus C here? So in that case I can simply write A cap plus A plus B minus C. It is having a value of AX plus BX minus CX, I cap plus plus AY plus BY minus CY j cap plus AZ plus BZ minus CZ k cap. Okay, you are going to get this expression here. So if you just put all the values here, so now you can see AX is 1, BX is 2, and C is minus 2. Plus AY is 2, BY we don't have any j component, so it is 0. We don't have any j component, again it is 0. Here we have 1, here we have 3, and here we have 4. Okay, so if you just finally calculate this value, you are going to get, it will coming out to be as 5i plus 2j plus 0 k cap. Okay, so here you can see we have to find out the value of the magnitude. So magnitude will be 5 square 25 plus 2 square 4, that means under root of 29 here. So option number B is going to be the correct answer here in this case. Okay, now the next part, a parametric equation of a curve traced by a projectile on a certain plant with no surrounding are given by y is equal to 8t minus 5t square and x equal to 6t meter here, where t is in second here. What will be the the velocity with which the projectile is projected? The velocity with which the projectile is projected is, okay, so let me just first of all just check what is this y here. So this y is here actually 8t minus 5t square here. Okay, and what do you want to find out? You want to find out the velocity with which the projectile is projected here. So in this case you can say in the velocity of the projectile we have to find out. So now you have to understand, in this case the velocity are going to have a two component. The one component is going to be along the horizontal direction, and the one component is going to be along the vertical direction. Okay, so we have to find out the each component from their respective displacement here. So I can say Vx is going to be equal to dx by dt, which will be equal to 6. Vy is equal to dy by dt here, which will be equal to 8 minus 10t here. Okay, and we want to find out the velocity with which the projectile is projected. So during the starting here, I can say the time is going to be 0 here. So I can say at t equal to 0, at t is equal to 0, Vx is going to be equal to 6 and Vy is going to be equal to 8. Okay, therefore the magnitude of the velocity, it will be equal to Vx square plus Vy square here. Okay, so if you just square them and add them, okay, and just find out the square root of this term, you will going to get the value of the velocity as 10 meter per second here. So option number C is going to be the correct answer in this case. Next part, the maximum range of the projectile fired with some initial velocity is found to be 1000 meter in the absence of wind and air resistance. The maximum height reached by this projectile is the, okay, so now in this case you can see we have to find out the value of the maximum height reached by the projectile here. Okay, so you have to use the direct formulas of the projectile, of the range here along with the height here. So first of all, just remember that the maximum range and the maximum height is achieved only when the projectile is projected with an angle of 45 degree here. So okay, so we can say here in this case the theta is going to be equal to 45 degree. Okay, and what is the formula of the range here? Range is having a formula of r is equal to u square sine 2 theta, r is equal to u square sine 2 theta upon g here. Okay, so this is the formula of the range. So just put all the values and get your final expression. So in this case, if you just put all these value here, sine 2 theta, sine 90 is going to be 1 only. So I can say the value of u square by g is going to be equal to 1000. Okay, now we want to find out the maximum height, and the maximum height is having a formula of u square sine square theta upon 2g. Okay, so in this case h is going to be equal to 1 by 2 multiply by u square by g multiply by sine square 45. So in this case, if you just calculate the value of the h here, it will be coming out to be as 250 meter here. Okay, so option number A will be the correct answer. Next part, a boat is sent across a river with the velocity of 8 km per hour. If the resultant velocity of the boat is 10 km per hour, then the velocity of the river will be. Okay, so in this case, just find out the resultant velocity. Resultant is going to be equal to the velocity of boat square plus velocity of river square under root. So here in this case, the resultant velocity is given to you as 10, velocity of the boat is given to you as 8, and the velocity of river is going to be given as VR here. Okay, so if you just solve it, you are going to get the value of the velocity of the river as 6 km per hour here. So option number B will be the correct answer in this case. Okay, now the next part, force of action and reaction never cancel out each other, as they are always equal, always opposite, acting on the same body. So I have already told you in my lectures also, the force of action and reaction never cancel out each other because they are acting on the two different bodies here. Okay, that is why they don't cancel out each other here. Okay, so option number D is going to be the correct answer in this case here. Now the next part, the mudguard over the wheel of a car work on the basis of. So now just see, if the car is moving along the vertical in the horizontal direction, the mudguard is also moving in the same direction here. Okay, if the car changes its direction, so again the direction of the mudguard also changes. So we can say the mudguard is basically working on the basis of the inertia of the direction here. And what is the meaning of inertia here? The inertia basically tells you about the resistance to the change here. Okay, so basically the mudguard is not changing its direction here. It doesn't want to change its direction here. So that is why I am saying it is working on the basis of inertia of direction here. Okay. Now the next part, two bodies having the mass having the same mass 40 kg are moving in the opposite direction, one with the velocity of 10 meters per second and other with the velocity of 7 meter per second here. If they collide elastically and as one body, the velocity of the combination will be, okay, velocity of the combination you have to calculate here. So in this case I can say you have to use the conservation of momentum here, okay, because there is no external force acting over the masses here. So let us say here we have a mass number 1, m1, it is moving with the velocity of u1 here, and here we have another body m2 which is moving along with in the opposite direction with the velocity of u2 here, and after the collision both the bodies are colliding with each other, okay, and they are just moving like one single body in any particular direction here, either left or either right here, okay. So we have to calculate the velocity of the combination. So let us say the velocity of combination is v here, okay. So in this case, according to the conservation of momentum, I can write m1 u1 minus m2 u2. Why I am taking the minus sign here? Because the two bodies are moving in the opposite directions here, that is why, okay. If you don't want to take the minus sign, that is okay, just take the sign of the velocity whenever you are putting the values in the general formula, okay, you are going to get the same answer. And after the collision they are acting like a single body, so I can say m plus m multiplied by v here, okay. So in this case I can write m is having a value of 40, u is given to you as 10 here, m2 is again 40, u2 is 7 here. Here we have 40 plus 40 into v. So I can say the velocity of the combination will be 400 minus 280 divided by 80 here. So if you solve it, you are going to get your answer as 3 by 2. Okay, so option number B, 1.5 meter per second is going to be the correct answer in this case here. Okay, now the next part, a force vector applied on a mass is represented by, so this is the force vector, and accelerate with the 1 meter per second square. What will be the mass of the body here? So now we know, according to the Newton's second law of motion, the force is basically equal to the rate of change of momentum, or I can write the force vector is equal to mass into acceleration here. Okay, so therefore the mass is going to be equal to force divided by acceleration here. But if you see in the values, the force is given in the vector form, acceleration is given in the magnitude form. So what I am doing, I am just calculating the magnitude of the force here. It will be coming out to be as 6 square minus 8 square plus 10 square divided by acceleration is 1 here. So I can write the mass is going to be equal to 100 plus 100 and mass is equal to 10 root 2 here. Okay, so option number A is going to be the correct answer in this case. Okay, option number A is going to be the correct answer. Now the next part is, a nucleus disintegrate into the two nuclear parts which have their velocities in the ratio of their nuclear size will be. Okay, so here first of all we have a nucleus. Now what is happening? It is disintegrated into the two nuclear parts here. Okay, and now it is moving with a different velocity, let us say v1 and v2. Now we have to calculate that what is the ratio of their nuclear size. Ratios of the nuclear size simply means we have to find out the values of the ratios of their individual diameters here. Okay, d1 and d2 you have to calculate it here. So in this case if you see, again there is no external force acting over this system here. Okay, all the forces are going to be conserved only. So I can say the momentum is going to be conserved, that p1 and p2. The momentum of the first body and the momentum of the second body are going to be remain same. Okay, the momentum are going to be remain same here. So I can say, let us say the first particle is having a mass m1 and the second particle is having a mass m2 here. So m1 v1 is going to be equal to m2 v2, and the corresponding velocity ratio v1 by v2, it will be equal to m2 by m1 here. Okay, which have the velocity in the ratio of their nuclear size. Okay, so you want to find out the values of the which have their velocities in the ratio of their nuclear size. Okay, the velocity ratio is given to us, the velocity ratio, velocity ratio is basically given to us, just wait a minute. A nucleus disintegrated which have their velocities in the ratio of, okay, actually in this velocity ratio is given to us and it is basically given as 1 by 2 here. Okay, the velocity ratio is given to us as 1:2. So in this case v1 by v2 is given to us 1/2. Mass I can write 4/3 pi r cube multiply by density 4/3 pi r square cube multiply by density. Okay, so I can say density will be cancelled out, so therefore the answer will come out to be as r1 by r2, it will be equal to 1 by cube root of the 2 here. Okay, or I can say cube root 2 ratio 1 here. So option number A is going to be the correct one only. Okay, now the next part is a body pushes the wall and fail to displace it. A person is basically pushing the wall here and it is failing to do so. So I can say the person is applying the, even though it is applying the force over the body, but it is not displacing at all. So I can say it is not performing any work here. Okay, so the option number D, that is no work at all is performed, is the correct one here. Next, for a perfectly elastic collision and the perfectly inelastic collision, the value of the coefficient of restitution, that is very easy here. For the elastic collision its value is 1 here, and for the perfectly inelastic collision it is 0 here. So I can say the option number D is going to be the correct one here. Okay, next part, how high must a body be lifted to gain an amount of potential energy equal to the kinetic energy it has when moving at a speed of 20 meter per second here. Okay, so in this case first of all a body is moving with the speed of 20 meter per second and it is going to attain some kinetic energy. Now what we don't want to do, we want to achieve this, we want to gain the same amount of potential energy. Okay, and how we can achieve the same amount of potential energy? By gaining some height here. So I can write half mv square is going to be equal to mgh. Okay, so in this case m will be cancelled out, or I can write the height will be equal to v square upon 2g, and v is given to you as 20 square, g is given to us, let us say 10 here. So if you just solve it, you are going to get the value as 20 meter. Okay, so if you just raise the height of an object by 20 meter, you are going to observe the same amount of kinetic energy as well as the same amount of potential energy if the body is moving with the 20 meter per second here. Okay, so that's again a very simple part. Now the next question, a body of mass 50 kg slides over a horizontal distance of 1 meter. Here we have a body which is having a mass of 50 kg. It is sliding a distance of 1 meter here. Now if the coefficient of friction between the surface is 0.2, so in that case work done against the friction. So now just assume, just see here, basically first of all due to the weight is acting downward here, and due to the downward acting weight, there will be a corresponding normal reaction which will be having a value of mg, and opposing to the motion of the body we are going to see the frictional force, and the frictional force is going to have a magnitude of mu into n. So I can say the frictional force is going to be equal to mu mg here. So now body is moving up to distance 1 meter only. So initially it is having some velocity, but due to this force of friction which is acting in the downward direction, the motion of the body is opposed here. Okay, and it is able to cover only 1 meter here. So I can say the work done against the friction, it will be equal to frictional force multiplied by distance here. So coefficient of friction is 0.2, mass is given to us as 50 kg, and gravity is given to us 9.8, and x is given to us 1 here. So if you solve it, you are going to see the value of the work done against the friction here. So it is coming out to be as 98 joule here. So option number A will be the correct answer. Okay, next, a force F is equal to 5I plus 3J plus 2K Newton is applied over a particle which displaces it from its origin to the point R equal to 2I minus J. The work done on the particle is, okay, So basically the force is applied on a particle and it is displacing the object from its origin to the point 2I minus j here. Now what will be the work done on the particle? So in that case, what do you want to find out? Can I say that you have to find out the dot product of force into displacement vector here? Displacement vector or position vector. So I can say the force is going to be equal to F dot R here. Okay, force is going to be equal to F dot R. So I can write 5I plus 3j plus k dot R is 2I minus j here. Okay, just perform the calculation and you will get your final answer. So how much answer you are getting here? You are going to get 10 minus 3 and k is going to be 0. That means the work is going to be equal to plus 7 joule here. Okay, so option number B is going to be the correct one here answer. So that's a very simple part. Now the last now the next question is, a force of 2I plus 3j plus 4k Newton acts on a body for 4 seconds and produces a displacement of position vector. Displacement vector is given to us 3I plus 4j plus 5 here. What will be the power used? Now what will be the power? Power is what? Power is basically the rate of doing work. So I can write power is work upon time and the work is force into distance here. Okay, so again just find out the dot product of force into distance and then divide it by the time here only. So you can see 2 plus 3, 6, 3 plus 4, 12, 4 plus 5, 20. So this will be the work done. Time is given to us 4 seconds. So I can say it is coming out to be as 38 by 4. The answer will be 9.5 watt here. So option number D will be the correct answer here. Okay, answer number D, option number D will be the correct answer here in this case. Now the next part, a car is moving along a straight horizontal road with a speed of V naught. If the coefficient of friction between the tire and the road is mu, then what will be the shortest distance in which the car can be stopped here? What will be the shortest distance the car will be stopped here? You want to calculate here. Okay, so how can you calculate here? So in that case, first of all, just see, here we have a car which is moving along a horizontal direction with the speed of V naught. And in this case, the coefficient of friction between the tire and the road is, coefficient of friction is given to us mu. So I can say the frictional force is going to be act in the opposite direction here. Then the shortest distance in which the car can be stopped here is, so can I say that the final velocity of the car has to be equal to 0 only. The final velocity of the car has to be 0 only. And in this case, the car is acted upon by a constant frictional force here. Constant frictional force. So first of all, just see here. Let us say the weight is acting downward, which is having a magnitude of mg. The weight is acting downward. Now in this case, the normal reaction will be n here. Okay, so I can say the frictional force is going to be equal to mu into n, or I can write mu into mg here. Now due to this frictional force, what is happening? The deacceleration is acting over a car here, which is basically stopping the car. So I can write the frictional force can also be written as mass into acceleration. The mass of car multiplied by acceleration, it equal to mu mg. So mass will be cancelled out, acceleration will be mu g. Okay, so this acceleration is acting basically to the acting opposite to the motion of the car here. So therefore I can write now using the law of motion, v square equal to u square plus 2as. Final velocity is 0, initial velocity is v naught square, acceleration is minus mu into g because it is acting in the opposite direction here, and s is the shortest distance. So therefore I can write the s is going to be equal to v naught square by 2 mu g. Okay, so option number C is going to be the correct answer here in this case. So again, a question is very simple but little bit tricky also. Okay, little bit tricky is question is there. Now next part is potential energy of a body is given by V is equal to A minus B square, Bx square. The what will be the magnitude of force acting on the particle. So we know that force is nothing but it is equal to minus dvx by x here. Okay, so if you just differentiate it, you are going to get 0 minus 2bx here, and a force is going to be equal to 2bx only. So we can say the force is basically proportional to the x here. It is not having a constant value, it is directly proportional to the x here. So option number B will be the correct answer in this case. Okay, the next part, moment of inertia of a hollow cylinder of mass m and radius r about the axis of the cylinder here is. So this is a direct formula based question. So in this case, basically the option number B, mr square, will be the correct answer. Mr square is basically representing the moment of inertia of a hollow cylinder which is having a mass m and the radius capital R. Next, a coin of mass 0.48 kg and radius 1 meter is rolling on a horizontal surface without sliding. Is rolling on the horizontal surface without sliding here with an angular velocity of 600 rotation per minute here. Now the total kinetic energy of the coin will be. So now in this case, just see the body, the coin is basically rotating here, along with that it is translating here. So I can say, if you want to find out the total kinetic energy, so you have to just understand that there we have two type of kinetic energy. The first kinetic energy is due to the translation motion, and the second type of kinetic energy due to the rotation here. Okay, and we have to consider both of them here. Okay, so in that case you can write kinetic energy is equal to half mv square plus kinetic energy is equal to half I omega square here. Okay, so I can write kinetic energy will be half mv square plus half I omega square. Okay, this will be the final formula. So now here in this case, V is nothing but omega into r, so I can write omega square into r square. And for the disk, the moment of inertia is having a formula of half mr square here. So I can write I is half mr square. So if you just simplify it further, you are going to get the final formula of the total kinetic energy of the coin as 3/4 mr square omega square. Okay, and the kinetic energy will be, mass is 0.48 kg, r is 1 meter here, and omega is basically 2 pi n by 60, 2 pi n by 60 here. Okay, it will be equal to 20 pi here, 20 pi square. So if you just solve this, you are getting the final answer as 1440 joule here. 1440 joule here will be the final answer. Okay, if you just calculate this value. Next question. An engine flywheel of diameter 1 meter rotates with an angular velocity of 600 revolution per minute. The linear velocity of a particle on the periphery of the wheel. That is a simple question. You have to calculate the velocity here. Okay, and velocity is going to be equal to omega into r. Omega into r is going to be the velocity. So in that case, you can just put 2 pi 600 by 60, radius is 0.5 here, and it will come out to be as 10 pi only. Okay, so option number D is going to be the correct one answer. Okay, option number D will be the correct answer here. Now the next part, angular velocity of a body changes from omega 1 to omega 2 without applying any torque, but due to change in its moment of inertia. The radius of gyration to both the cases is. Okay, so angular velocity is basically changing without applying any torque due to this change in its moment of inertia here. Okay, what will be the radius of gyration in both the cases here? So in that case, first of all, just see, we are not applying any torque, we are not supplying any external energy into the system here. So that means the conservation of the momentum in the translation case, and in this particular case the conservation of angular momentum is going to be there. So I can write basically the angular momentum is nothing I into omega. Okay, it is going to be remain same. So I can say I1 by I2 is going to be equal to omega 2 by omega 1. Okay, and I1 is going to be equal to m k1 by k1 square divided by m k2 square. Omega 2 is given as omega 2 by omega 1 here. Okay, so here you can see you want to find out the value of the k1 by k2. K1 by k2, it will be equal to under root of omega 2 by omega 1. So I can say the option number A will be the correct answer here. Okay, so A will be the correct answer here in this case. Now the next part, a wheel having a moment of inertia 2 kg meter square about its vertical axis that rotates at the rate of 60 revolution per minute about its axis. The torque which can stop the wheel rotation in 1 minute, it will be equal to, okay, so I is given to you 2 kg meter square. It is rotating at the rate of 60 revolution per minute. So I can say n is 60 rpm here. So therefore initially it is rotating with 2 pi radian per second. It is rotating with this particular speed here. Okay, 2 pi n by 60. Now in this case you are applying some torque. That means during the application of the torque there will be certain angular acceleration which is stopping the disc here. So we know finally the angular velocity is going to be 0. So therefore I can say omega 2 is going to be equal to omega 1 plus alpha t. Omega 2 is equal to 0, omega 1 is 2 pi here, alpha we have to calculate here, t is 60 second here. So I can write the alpha is going to be equal to minus pi by 30 radian per second square. Okay, so this much angular acceleration has to be applied on the torque, applied on the disc to stop the wheel rotations here. So in this case I can say torque is going to be equal to I into alpha. I is 2, alpha is minus pi by 30. So answer of the torque will come out to be as pi by 15 here. So option number B is going to be the correct answer. Okay, so again the part is very simple. Now the next part, a flywheel has a moment of inertia of 0.5 kg meter square. What torque to increase its velocity from 2 pi radian per second to 15 radian per second in 10 seconds is required basically. Okay, so now again in the previous question we are applying the torque to reduce the rotation here, but in this question we are applying the torque to increase the rotation here. So I can write again the omega 2 is equal to omega 1 plus alpha t. Now here the final omega 2 is 15 pi and initial omega is 2 pi here and the time is 10 seconds. So therefore I can say the alpha is going to be equal to 13 pi by 10, that is 1.3 pi. What will be the torque then? It will be equal to I into alpha and I is 0.5. Okay, how much answer you are getting? You are getting the answer as 0.5 multiplied by 1.3 multiplied by 222 by 7 here. Okay, so if you just simplify it further you are going to get the final answer here, and if you just see the answer will come out to be as, answer is coming out to be as 2 Newton per meter. I think it is coming out to be as option number C here. Okay, just calculate this value and you will get your final answer. Next, which of the following orbit is a possible orbit for a planet here? So just see, first of all C and A will be the wrong answer here. Why so? Because here in this case you according to the Kepler's law here, sun has to always be at some of the foci here. Okay, it has to be placed at one of the foci and the planet has to revolve around the sun here. So option number A and option number C will be eliminated here, because in this case the sun is in the center and the planet in the third case the sun is on the orbit here. Okay, so option A and C will be eliminated here. But now if you just see out of the B and D, what can be the answer here? So in this case the option number D will be the correct one. Why? Because this is not a location of the foci here. Focus are basically located on the semi-major axis here. Okay, that is why the option number D will be the correct answer here. Next part, average distance of the earth from the sun is L1 if 1 year of the earth is d days and 1 year of the another planet whose average distance is L2 from the sun is. Okay, first of all, just see here again we have to use the Kepler law. Basically the law of period is going to be used, and according to the law of period, the time period of any planet is directly proportional to the revolution of the planet. Okay, the cube root of the cube of the revolution of the planet here. So in this case you can see 1 year of the earth is having the d days. 1 year of the earth is basically the 365 days here. Okay, and the 365 days is the time taken by the earth to revolve around the sun here. Okay, so I can write T2 square by T1 square, it will be equal to R2 cube by R1 cube here. So I can write here the T2, what we have to calculate? We have to calculate the average distance now. So we have to calculate the average distance from the sun. Yes, average distance we have to calculate. That means we have to calculate the R2 by R1 only. Okay, we have to calculate the R2 by R1 only here now in that case. So I can directly write T is going to be equal to T2 by T1. It is going to be equal to R2 by R1 to the power 3 by 2. That you have to calculate it here. Okay, so in this case if you see, average distance of the earth from the sun is L1 here. So I can write, okay, so now just see the time period of the revolution is given to is unknown to us, and for the earth we know its value is d here, and the distance between the planet and the sun is here is L2, and the distance between the earth and sun is L1 here. So I can directly write the 1 year of the planet, the 1 year of the another planet d dash is going to be equal to d multiplied by L2 by L1 to the power 3 by 2 here. So in this case the option number B is going to be the correct answer here. Okay, B is going to be the correct answer here in this case. Now the next part, the mass of the moon is 1/8 of the earth, but the gravitational pull is 1/6 of the earth here. It is due to the fact here, actually this question again is a very simple case. Okay, so first of all in the question given data is mass of the moon is 1/8 of the mass of the earth here, and the gravitational pull of the moon is 1/6 of the gravitational pull of the earth. Why it is so, we have to calculate. Okay, so now in this case if you see, gravitational pull of the moon divided by gravitational pull of the earth, it can be written as GMM divided by RM square GME divided by RE square. So G will be cancelled out. Mass of the moon is 1/8 of the mass of the earth here. Okay, and if you just see RE by RM square, this data is given to us. So here if you just put all the values, GM by GE is given to us 1/6. It is equal to 1/8 radius of earth divided by radius of moon here. So I can directly write the ratio of the radius of earth and the ratio of the radius of moon is equal to root of 8/6, and due to this reason the gravitational pull of the moon is 1/6 of the earth here. So option number C is going to be the correct answer here in this case. Okay, next part, the escape velocity of the body from the earth depends upon the mass of the body. It is wrong here. The escape velocity does not depend upon the mass of body here. The location from where it is projected, that is correct here. The direction of the projection, that is also not the direction of the projection, that is also not a correct answer here. Okay, the next part is, okay, direction of projection, it is also a wrong option here. The location from where it is projected, yeah, it depends basically on that. Why so? Because the escape velocity is having a formula of 2gm by re here. Okay, so this is a formula of the escape velocity here. So in that case if you see, it is basically depending upon the gravitational constant, it is depending upon the mass, and it is depending upon the radius here. So that means we can say it is depending upon the location where it is projected here. Okay, the direction of projection it is not depending upon. So I can say the option number A is eliminated, option number C is eliminated, and option number D is eliminated. So B will be the correct one here. Okay, next part, if VE is the escape velocity and V naught is the orbital velocity of a satellite for the orbit close to the Earth's surface, then they are related to each other as, okay, so now just see in this case the escape velocity of the Earth, it is having a formula of 2gme divided by re, and if we talk about the velocity of the orbit, it is equal to 2gme divided by re here. So the how they are related to each other, so in this case I can say the escape velocity is nothing but it is equal to how much value you are getting, under root of 2 V naught. Okay, this is the expression you are going to get. So I can say the ratio is coming out to be as VE is equal to root 2 V naught here. Okay, now the next part, the time period t of a moon of a planet mass is related to the orbital radius, r as g is equal to the gravitational constant here. So in that case, so first of all just see the time period of the planet moon, planet moon is given by 2 pi r divided by gm of moon divided by radius of moon here. Okay, this is the expression, this is the expression of the time period of not the moon, of the Mars here, of the Mars planet here. Okay, so in this case just put all the values and you are going to get the final answer. So here in this case if you just put all the values here, so what is given to us, to the orbital radius. Now we have to compare it with the orbital radius. Yeah, so here if you just see the expression after simplification is coming out to be as 2 pi r 3 by 2 divided by gm under root, you are going to get this expression, and in the options the value is given of 2 t square na, so it will be 4 pi square r cube divided by gm here. Okay, so I can say the option number A is going to be the correct answer here. Okay, students, so here we have covered the entire important questions which are there in the +1 physics here. Okay, so I hope you like this question series here. Okay, so just practice all of these questions one again time and you are going to see that the similar type of question has been asked in the exam also. Okay, because in the exam some one-liner numericals is going to be asked there and some theoretical portion is going to be asked. So make sure, ensure that you practice all of these questions here very carefully. Okay, so thank you very much.